All right. Okay. All right, class. Sorry. Everyone speaks and you won't hear me. Can you hear me? Yes. All right, great. Okay, welcome back. Sorry again, I wasn't here last week, but I hope your TAs did a great job teaching you something. If not, send me a letter, like an email. All right, so before we start, a couple of things we want to talk about. First thing is that we officially got the email from Google. So it's December 12th, I think it's 10 a.m. We'll be at Google and we will send out some registration information for that. The idea is that to make this more tasty for you guys is that we are inviting industry partners, other companies to come see your work. Okay, so you can use this as a platform for yourself to promote what you are building. At Google is also using it as a platform to promote what you can build on our platform. All right. So what does that mean? That means is basically take it more serious. You know, it's just kind of like whatever you're building, whatever you work with your team, try to address everything that you learn in this class. Okay. Judges will be myself and I think 3 engineers from Google, and then it will be like an audience voting also. Right? But one thing that's really important is that we say judges and they're going to be like voting and stuff like that. Your end goal shouldn't be that, okay, I'm going to be winning or not, right? So even if you're winning, you just and maybe you get a letter, right? Your goal should be that you are going to learn something here. Okay, so that's a wrong reward system we have everywhere, but that's a reality. We're just trying to make it more tasty. Okay, so but that shouldn't be your end goal. Okay, even if your project comes last, like your lowest rating, still you did a great job. You built the product, right? So just that should be the goal that you have. Okay, that's one thing. The second thing is that before we start, we want to talk about your teams. Okay, and because I feel like there are lots of students that you don't have any teams, right? Who doesn't have a team? Okay. Just raise your hand. Don't be shy. We're trying to help here. Should be more than that based on our estimate. Okay. And how many of you have less than 5 team members? Okay. And the rest of anyone sitting on the right, you all have 5 or 6. Okay. So for those of you, and also how many of you have not filled the form that we gave you for, that Excel sheet that you needed to fill? Is there anyone that you have not filled?
The Excel?
The Excel sheet.
The final assignment.
Now, the Excel sheet, which basically says that about your background and if you have any experience in certain things. If you have not filled that, please do that because we need that data, and also that's how we can help prepare if you don't have anything. For those of you that you have less than 5 team members, you need to reach that number, bring that number to 5. Okay, and it's not because we need you to have 5, it's you need to have 5 yourself. Okay, any other semester, the teams that you had less than 5, those are the teams that normally come on the bottom because they don't have enough time, and what they do, they cut corners, right? So basically, they're not going to be able to implement everything. So you need to be sure that you have a minimum 5 players in your team. Okay, if you have any issues with finding team members, just reach out to me or your TAs, first your TAs if they couldn't help, then me. And then we will assign or basically try to match, not that we will say this person will join your team, but we will give you a recommendation. These people or these other students, they want to work on the same domain, and you basically need to pair up with them. The other thing that I noticed is that almost lots of you guys want to do finance. Right? What's going on? Seriously, this is the only semester that we do finance. Every other semester we had like one team or 2. Is it a change in the market? No, seriously, like you have a finance background or yeah, job market. Okay, so when you pick something like finance and healthcare, it's actually more challenging than other, like if you go, for example, tech, because there are lots of regulations, and basically alignment and like guardrails that you need to account for. And that normally means that you or someone in your team need to have some domain in finance, domain knowledge in finance. If you don't have it, you can use ChatGPT to figure out this knowledge, but you need to account for it. The other thing is that when you pick a domain, you also, which is part of today's class, we're going to talk about it, you need to also figure out, do you have an idea where you get data for it? Okay, because you are responsible to find the data for your product, right? So if you pick finance, be sure that you have an idea of where I'm going to get this data from. And I think the final thing that's kind of like important is that whatever project or the idea that you have in mind, you need to be sure that you can basically deliver at it. Okay, so don't pick an idea or don't basically try to form group because there's something that sounds really tasty, right? It's kind of like something that sounds really good. So you think there's a big reward at the end for delivery, because that just makes it more challenging for you to deliver something at it. Okay, so just be sure that you think carefully on those. Now, any question on that before we start? Very good. All right. So today we are basically going to start with a concept called scoping. Okay, and this is going to be your first deliverable. The first basically submission that you have for your project is going to be the scoping document that you're going to send. Now, the idea of scoping is that you want to build a product or someone comes to you and say that, hey, I want to build a product. In this example, there's an e-commerce basically where try to increase their sales. Okay. Now, let's say you have your consultant. You're a consultant, and someone comes to you and say, hey, we want you to build something that helps us to increase the sale. Now, the question is that, well, do they need a better recommendation system or a better search? Do they need to improve the catalog? Do they just need to do a better inventory management or item like a price modification? And then the questions that you need to ask is that, okay, what project should we work on? What are the metrics for success? What is the resources we need or stuff like that? I'm going to break all of this down. But that's normally this is the first step of any project definition of scoping. Now, the scoping starts by first a question which is not AI related. It's a business related question. So you first need, as part of your scoping, identify a business problem. What we are trying to solve. It shouldn't, think about this. Most of the time, engineers, when you try to come up with an idea, the first thing comes to your mind is that how to optimize something, right? How to make something faster, how to build some cool tools. We don't think like, what's the business problem? What's the need for something? And I go basically build that. So as part of the scoping, doesn't matter if you're a part of the company or you're working for a company like as a consultant, you need to first identify the business problem. Okay. Then you brainstorm AI solution. And brainstorming AI solution basically means that, well, do we need AI for this? Do we need machine learning for this? You know, could it just simply be a rule-based system? You know, could you use something, maybe you don't even need any of this. You just need a better sales engineer or sales, right? The other one is that assess the feasibility of and value potential of solution. Like, is it feasible to do something like this? One of the ways, like if you work with machine learning, this is a question for you guys. Let's say you have I give you a data set, and then there's an idea that someone tells you to do a classification, right? And what's the easiest way to quickly for you to see that if this problem is solvable by machine learning?
Have enough from each class.
Let's assume the data is perfect. What would you do? Like this quickly to just give an answer that this is feasible one. Correlation. I mean, correlation is statistically, yeah, but it's not the causation. It's not, that's mean that you can solve it, right? It's not wrong, but it just gives you some correlation. Let's say you have so many dimensions, right? Which one, across which dimension would you look at the correlation lines?
So we check how many classes are available, like how many classes we are classifying. If it is too high, then it does not make much sense.
So, but what you said is not correct. But these are things that take time for you to go do the analysis. You want a quick answer. Someone reach out to you via email. You want to quickly give an answer that can be given or not.
Is the data recent? Is the data recent?
Let's assume data is perfect, recent, no cleaning issues.
You can see that if anyone else did it previously.
That could be one idea.
See how much return of how much value we are getting in profit after we do that.
But that's a business problem. Someone already coming with a business problem to you and ask you that to solve a solution.
If there's not much variation in the data set and anyone can identify a pattern and can classify it. So there's no need to divide.
So what if you just simply pick a model and overfit it to the data? You pick it, you have a data, you bring a machine learning model and see that can you memorize this data? If you can overfit it, that means the AI can memorize the patterns, right? That could be a really quick way for you to say, okay, is this solvable or not? If you, even on the same data, you cannot get a good accuracy, like a training on the same data and testing it on the same data, you cannot solve it, then it's not solvable, right? At least with data. So there's not, again, everything that you say is correct. That's what we're going to break down. But the easy way is that always just quickly overfit the data and see that it doesn't work or not. Then you need to determine milestone. The milestone is like, to break it down, how long it's going to take. Normally, you want, depending on the companies that you work on. If you work in the startups, you want something quick. You need to be agile. That means the smaller deliveries and then faster basically worker. If you go to a larger corporation where the teams are kind of like a spread along, sometimes you have multiple projects and then maybe the process of the milestones are kind of like long, right? And then budget for resources. And budget for resources means that, well, okay, if I want to build this project or product, what do I need? How much money is going to take? Which engineers do I need? Do I need a data scientist? Do I need a data engineer? Do I need a software engineer? How many I need to pick from every team, right? That's overall that plus the cost of the AI that we're going to use is going to be total budget, right? Now, for the example that we say the e-commerce, the top things that you basically could do to make it better is that to increase the conversion, to reduce the inventory, and increase the margin. Those are the top three things, let's say, for example, you can do. But now you need to start by separating problem from the solution. Now, what could be the problem? The problem is that you want to increase the conversion. And what could be the solution for that? Well, you could have a better search and better recommendation system. The problem could be that we want to reduce the inventory. What could be the solution for it? Demand prediction and marketing. The problem could be we want to increase the margin. What could be the solution for that? To optimize what to sell, to bundle basically what to sell. So you need to have an idea of like what is the problem and what could be the solution to be able to separate this from each other. Now, let's talk about diligence and feasibility of values. So, first thing is feasibility. How many of you have heard the term HLP or human level performance? So, great. You want to tell us what do you think of HLP?
It's a human baseline performance.
Correct.
AI.
And why do you think we do that? Like why we use that?
See if your system is better or worse.
But yeah, but why humans?
What else? Animals?
I mean, in some cases, animals are like if you do a memory test, so and especially if you do a short memory, monkeys are much better than humans. So if you put basically puzzle in front of them and increase the speed of the process, they have done this test. It is actually an academy in Japan for that. Monkeys always win, like really good. Like humans, we don't have that really good memory because we lost that ability by instead we learned how to speak. That's a theory. So feasibility, basically the question is that is this project even feasible? Now there are two types of questions. First, is my data unstructured or is my data structured? Unstructured becomes data like text, audio, picture, and stuff like that. And structured, anything which is tabular, basically. When it comes to unstructured data, we always use HLP, human level performance. And why? Because we are really good with unstructured data. Audio, you hear something, you quickly can detect it. Seeing something, our vision is really good. But when it comes to structure, a table has more than 10 columns, more than 10 rows. You can't read it. It's hard, right? Because we are really bad at that task. So anytime there is unstructured types of basically data, you want to use human level performance. And that's why all these AI tools that we see, they always have a metric that compares them like how human rated, like in compared to humans. Now, the next question is that, is this capability that we're adding new, or is this something that already exists and we want to improve it? If it's new and unstructured, you definitely need human level performance. That means you need to bring humans, set of data, give it to humans and ask them to basically give the answer and do the average. That becomes the human level performance. And your AI goal should be that to be as far with humans, right? Over time, you can get better, but that shouldn't be the end goal, but at least to meet the minimum. If it's an existing, that means you already have some AI capabilities or machine learning capabilities, and you want to just improve it. In that scenario, you're going to use HLP, human level performance, and the history of the project. What does that mean? That means if previously you had a certain, like let's say, accuracy, but the new development that the new cycle that you release has a lower accuracy, and that's something. So you basically need to account for previous basically performance history and the human level performance. when it comes to structured data, if it's new, that means you haven't built this before. The first question is that, is this data that we have, the structured data that we have, does it have the signals for making this prediction, or basically for developing this model? And if it's something that already exists, well, are we adding new dimension to it, or is it just, or are we just adding new rows, basically? So it's the reason that we are trying to improve it, or just some retraining cycles. So those are the types of things to keep in mind. So you always for HLP, can a human, given the same data, perform the same task? Right? Actually, that's these days when you want to develop agentic AIs, you have heard the term context, right? So if you pass the same context to an agent or LLM and get an answer and bring a human level of expertise, like someone in the expertise level, and give the same context, whatever the LLM sees, and ask them to provide the same answer, you can basically identify if the LLM is doing a bad job or not. Right? And that human cannot be someone random. If it's a specialized task, it should be someone with that domain knowledge. Like if it's medical, for example, you bring some radiologists and give them the same image and see that, okay, what's your finding in it? And you give the same thing by providing it to an AI. Right? So that becomes a comparison. Now, why we use HLP to perform as a benchmark? So look at this example. On the image on the left, you can look at the light and you see green, right? On the image on the right, what color do you see on the traffic light? This one thing is green. It could be any of those three, right? So that's the problem. If you have a data that, or a light, something like that, that doesn't matter who's looking at it. You're like, could be green. What if you went through the light and it wasn't green? Right? So if you have a data like that, that's one of the things that we're going to either try to figure out, fix it, change the resolution to see if we can improve it, or we just need to remove a data like that from training. Because what it does, it just generates some random result by it. Right? So now, when we go to structured data, and you normally want to ask questions like this, that, okay, can we solve this using ML? For example, given past purchases, predict future purchase. Do you think you can do it? Yes. Given weather, predict shopping mall foot traffic. There's some correlation over there, so probably. Given DNA info, predict heart disease. Lots of startups are working on ideas like that now. Given social media chatter, predict demand for closing stock. Yeah. Given history of a stock price, predict future price of the stock. Yeah. Stock is one of those scenarios that you always fail. You always think that you have a good model and it fails. And that's one of the reasons if you at some point in the future you work in the stock market, you see that the model that you have, you can basically retrain it much often. It's pretty fast. And an idea you can think about is that things could be really time sensitive. Something could go up, I don't know, within an hour, and then all of a sudden start going down. So you need a model to quickly predict something like that. So your window is much shorter, right? So and it's normally it should be something, an easy model that you can retrain it quickly without a cost. You're not going to use LLM or things like that. Now, when we talk about history of a project, so and this is something that you will deal with if you will work in some companies. There's always this request that we want 99% accuracy. Get go. You just started working on a project. The first definition that your boss gives is a 99% accuracy, right? And that's reality. Doesn't matter who you always unless the person who you work with, they have an understanding of it. They're like, okay, we're going to gradually improve this. But what you want to understand is that instead of saying that, okay, my goal is to reach 99% or HLP, you could say something like that. In Q1, we're going to have 10% error. And Q2, we're going to have 7.5% error. And that becomes your gradual goal. And you can basically say that, in a year and a half, we're going to reach that number. Right. So you need to be realistic based on the history of the project. You know, if all the models exist in the market right now is like a 90% accurate, why do you expect me to all of a sudden have 99% accuracy? So you need to basically have this understanding of the history. The other one is that the diligence on values. So anyone here has studied or basically have some business knowledge or product management? So what's your friend? What's your name? Sorry.
Jules.
What was that?
Jules.
Jules. So Jules, you basically probably know this. There's always a really big difference between business metrics, what the company defines as business metric, and the engineering metrics, right? Engineering, we see everything as some sort of like a constraint and something that we want to solve. In business metrics, you see everything as some sort of like a revenue, like you want to increase the sales or increase the revenue. And when these two teams work together, most of the time there's a clash of culture, right? What they want versus what you optimize for. In engineering, we need something measurable to optimize for, which is all our objective optimization functions are like that, right? So let's say you work on a project and the business goal is that, okay, we want some sort of like an increase in revenue. And it's like a search engine. And from the engineering perspective, well, the model that you develop is basically you optimize it for word level accuracy. How could you map from word level accuracy to somewhere that's basically the business team can understand? You know, your goal is to come up with that proxy, how to map this to that. So instead of maybe your model trains on word level accuracy, but then you map the word level accuracy to query level accuracy. Then from there, you can say that search result quality. Search result quality is that it means if user, for example, keep coming back to your platform, they like the answers that you are getting, you know, that's going to have a good search result. That means automatically, and that's not your goal, but you can proxy that. That means you have a higher user engagement. Higher user engagement means that you have a higher revenue, right? So your goal is that to basically find this proxy between the engineering metrics versus the business, right? And if that's it's kind of like it normally happens, like you have some lead in your team that basically the cross, you know, it's kind of like a cross-functional team. You sit with the business team, you sit with other partners and try to understand what they want, what you can deliver, and then, you know, where you can meet. Now, the other one is the ethical consideration, which is pretty interesting these days, right? So is this project creating a net positive social value? Is this project reasonably fair and free of bias? Have the ethical concern of this project been openly discussed? You know, there's a type of thing that you can ask, but why do you think you need to ask this? Like, why should you care for the ethic? If you are just an engineer, right, and you just build whatever they tell you, right?
Yes, you can get sued.
But that's just correct. If it's your own company, yes, you get sued easily, right? But if you work in a company and if the company gets sued, you can say that, oh, the company does. I didn't do anything wrong. But well, let's say it's not your company, you're working in a company, they ask you to build something. Why should you care?
People are getting affected by what you're doing. So
That's correct. So one of the things is that, well, it impacts others, and at some point, probably it will impact me, right? And maybe your model is like a 98% accurate, but again, just a simple example is that let's say you have a model that is 99% accurate for selling, like promoting companies, right? 1% is doing a bad job. When you look at that 99% is normally high brands and companies with you know, lots of money that you're doing good for them because they give lots of basically requests to you, so you have lots of data. That 1% is every small company that comes to your platform for the basically advertising. So they're always going to have a bad search result or bad promotion in compared to large companies that they put lots of money, right? So it's kind of like important to be sure that you're free of bias and other social values. We're going to talk about this. Now, milestone and resourcing. So when it comes to milestone, some specification like questions that you need to basically keep in mind. So what are the ML metrics that you need to use for this? So when you right now for your product that you are planning to build for this semester, as part of your scoping document, you need to come up with this information. How you're going to measure it? What's the metrics that you are going to use for your model? That's ML or AI model that you're okay. And that's not the software metrics. Software metrics are like things like a speed of like the speed that you have, or basically the throughput you have, and stuff like that. This is focusing on the model specific accuracy level. Then business metric. What's the business metric that you have here? It's like okay, the end goal is to increase the revenue, right? And then what's the resources you need? Data is considered as a resource. Personal that you need, consider resource. And if this personal is not part of your team, is coming from a different team, you need to also account for that, because when maybe someone you need to borrow someone from another team only 2 days a week. That's common. Like they already have their own project, maybe a day or 2 days a week, they can work with you on your product. So those are things that to keep in mind. Yes.
How do we come up with the business metrics if the project or software hasn't been gone public yet?
So let's say, so what you're asking, let me rephrase it. You're saying that I'm building something that doesn't exist in the market, right?
Yeah.
And it hasn't gone public, and I'm just building it at home right now. How could I build basically a business model? So why you are building it? What's the end goal that you have? Is it just to build something, or your goal is to have a company? What's the goal of that company? If it's a startup, normally you would say that I want to be a unicorn, right?
All right.
So you have some goal still, you have some goal. And think about it, when you do build the startups, you need to do fundraising. Right? You can't go to an investor and say that I want to raise fund if you already don't know what's your business. So you need to have a business, and you need to have a plan for it. I have a plan that by this year, I'm going to have this much ARR, for example. Right? So there are some metrics that you need to have a plan for this. And where do you get those metrics? Normally based on the rest of the method. Maybe someone hasn't built exactly what you have, but let's say you're in finance, so you know what's the market cap, how much money is in this market, and how much people are going to invest, so you can estimate and build that basically business plan.
But in the end, it's just a prediction, though.
Yeah, so I mean, you work toward a prediction, right? But think about it: 90% of the startups, they don't raise money, right? They don't even go Series A, because it's challenging. You could spend a lot of time work towards something, but at the end, it's an idea, right? So that's the same. Now, so you can basically, and it's just an example from a website called Made with ML, create some sort of like a template for yourself. Every time you want to work on a project, or any company that you go, you could have this template that if I want to start a new idea, I'm going to do something like that. There's some background stage, some value proposition, objective, solution, feasibility metrics, inference, project, so it's just a template. But having a good template for yourself is always great, because every time you want to start something new, you don't need to think of what do I need. You're always like, okay, I need to basically address to these questions. Okay. Now, so that was just concept of ML. Now, these days, when it comes to LLM, things are a bit different. When it comes to scoping, especially since ChatGPT, because now every company wants to basically build something with LLM, right? Now, the common questions that you will get is that how long does it take? Is it going to take 3 months, 6 months, a year, or more? Right? So it's always a question, and it's kind of like a open-ended question. How much is going to cost me? It's like 50,000 is going to be 10 times more. Right? So this is a type of thing that's kind of like unknown. You can easily start working on a simple LLM project by using the wrong model or wrong API and just have a huge cost, versus someone else to just do a local model with almost no cost. Right? And these are all different for different companies. Now, the first thing that you basically could figure out when you want to work with LLMs for your product is define a use case around a real problem. So always start small, but solve something meaningful. Okay, so that means that don't aim too high. I don't know if you heard probably recently, the new Gartner study showed that 95% of the AI project have failed over the last 2 years. Right? Every company is spending lots of money, 95% does fail. But what does fail means? If you read the basic article, fail doesn't mean that they couldn't build it. You know, engineers, they build it. It doesn't sell, or it doesn't basically end up, the customer is not happy with it, or something like that. It's not what the engineering concept is like as an idea, as a product, right? So what you want to do is focus on things like process that are repetitive or inefficient, right? Especially like if let's say, we do naming, or like we are working on something that engineers, they work a lot with the PDFs, you know, in defense, that basically they want to build something, they have this PDFs on the computer, they need to manually enter things. We automate that process, because now as an engineer, you don't need to do that. You can just quickly have this document to an AI and just like hours of, like sometimes days of work, depending on how many page PDF that's. That's kind of like an inefficiency. Then, or you're working in a domain that, you know, has lots of specific jargons, right? And then AI could basically be pretty helpful, especially fintech, right? Because it's like I had lots of jargon. Or the outcome directly impacts the business metrics. You have a specific goal, and you know that this, if we build this, it's going to directly improve the business metric. Now, your goal is that to simplify goals. Don't try to overestimate. Now, similar to ML, you have basically 2 ideas. One is that, are we building new capabilities using LLM, or are we streamlining an existing inefficiency? Or we're basically improving something. If you are building a new capabilities, you basically, that idea is that you want to use your domain expertise or someone in your team, you know, to build something that doesn't exist, right? And basically that is going to directly impact your customers, because you're improving the user basically experience. On the other end, if you're streamlining some inefficiencies, that means you already have tasks that are being done. You have people doing it, but it's kind of like a tourism, like you are not happy with, right? So, you have a question? Have you seen that meme that says, I want AI to do my chores, like dishes and stuff like that, and so I can do my painting or something like that? So that's something like that. Now, let's say you want to enhance customer service, right? So how many times have you gone on a website that has a chatbot? When you talk, it has a repetitive answers. Like it is no AI, it's just basically like a regex search, and gives you fixed answers, right? That's where the basically LLM can help, right? Because over there, that's customer service representative, basically can get the dynamic answers, like this is when you talk with any of the GPTs, right? Any of the platforms, they have a memory of your past interaction. They can dynamically pull data and be able to answer. Like Amazon does a really good job. Sometimes when you have a question, especially if you do a return, most of the time, if you just talk with the chatbot, it's done. It says, okay, we refund you the money. You don't need to go on a call or wait for a representative or something anymore, because they already look at, pull the data, and they basically can do that. So what's the impact of that? You will have a happier customers, that gives you brand advocate, and normally you have a lower churn, hopefully. And that helps you with business growth. Now, the second thing when you work with LLM is to assemble a cross-functional data. So when you scope, you need to have a collaborative team. It shouldn't be just engineers, right? Because again, engineers, we have a really narrow focus on certain things. So you need to have data scientists, data engineers, software engineers, product managers, and someone from the stakeholders, someone with a broader business knowledge. Now, especially if you look at the bullet 3, if talent is lacking in-house, to start with consulting. That's really common. Sometimes companies, you want to build something, you're like, we don't have that knowledge. How should we build it? Is the easiest thing is that just you hire some consultant. They help you to get on your fit. and then you continue from there. Meanwhile, you learn the idea, or you learn the process, or you basically, maybe you hired some new people and continue. Instead of waiting to learn, you can speed up that process by working with some consultant and then continue from there. Now, and this is what I will say, engineering is not product again. We have a narrow focus, product owner is kind of like a care about the user experience. So you want to basically balance it. How do we balance that? We need to have a clear problem definition, realistic, basically scoping, and faster iteration cycles. Don't try to have like a, I don't know, deliverable every month, maybe every week or every 2 weeks maximum. You need to basically have deliverables. Faster iteration is always better. The next thing is that create a data product requirement. And this is something that you also need to do for your product, okay? And data product basically helps you to align the business goal with the engineering goals that you have in mind, okay? So basically it should be easy to read. It's not going to be part, it's not your scoping document. It's going to be kind of like a lightweight version of that anytime someone wants to understand that what you are doing, they can quickly refer to that. Or if you want to freshen up your memory, you can quickly refer to that and basically read that. Okay. Now, in summary, like what to include in your data product document? What's the purpose of this project? What's the data source? Like where we get this data? The architecture diagram. The question that always we have every semester is that, well, at first I don't know the diagram, right? And that's where you don't need to architect the diagram precisely, but you need to have an idea, like if I want to solve this, these are the things that I need. If you don't know it, you search basically, right? But you need to have an idea of how this data comes through, where it goes, and how it basically provides the output to the user. So you need to architect that diagram. Dependencies, like who do you need for it? What basically resources do you need? What tech stack do you need? Do I need to add additional team members to my team because we're lacking certain basically capabilities? That's something to keep in mind. Evaluation metrics and feedback monitoring frameworks, especially if you like it doesn't matter ML or AI, like LLM, but you need to be sure that feedback and monitoring basically is really well defined. When it comes to LLM, it's kind of like a bigger picture basically, because the output that you get is not precise. It's kind of like could be free text, could be generated video or image. So you need to have a better monitoring over there. Now, the next thing is that choose the right LLM for the job. You know, it's just not all LLMs are the same. You all have probably experience with, but be sure that you have an idea between open source or basically closed source. If you work with closed source, they might be more powerful, but they might lack that knowledge or capabilities to your domain specific data. Lots of time companies, that's the issue. Like you can work with ChatGPT, has a great general knowledge, but your company might have some proprietary data that doesn't exist online. And if you try to ask any of those models, they basically fail to provide you with answer. So now, on the other hand, when you work with open source model, you can fine tune them however you want. And this fine tuning is getting cheaper and cheaper, right? If you, I don't know if you're following Hugging Face, last week they passed 2 million open source models on Hugging Face. They announced. So there are 2 million LLM models, open source models, basically out there for you to not all LLM, but like open source model on Hugging Face for you to basically pull and do some sort of fine tuning and use it for your domain specific problem. And then you have a greater control over the features and IPs, and also it's ideal for a specialized high accuracy application. But one thing that you need to ensure that you are aware of, when you work with open source models, especially if you do through Hugging Face, or even directly from the GitHub or wherever they put the model, read the license. Okay, not all models could be used in every place. Okay, so it's kind of like there are rules. Like in my domain right now, that we can't work with any llama models in defense. It's specifically says that you cannot use that. All right, so gammas, I think like certain of them you can, certain you can, and there are lots of like Chinese models that you cannot. So there are rules for your domain. be sure that you just simply don't go pick the best model. You need to read that. Can I use it? Right? So you can simply, if you don't want to read the entire license, copy that license, give it to your AI and say that, can I use it or not? It summarize it for you. Now, why should we do transfer learning or maybe something like doing domain adaptation? Because generally these models are pre-trained on large corpora, and then you can do a fine-tuned one on small domain-specific data. And the benefit is that they have a lower compute. You can quantize them, for example, to run on a smaller number of GPUs, and then you have full control over deployment. And you also don't deal with random updates that it's kind of like, I think Gemini recently did something like that. They did an update recently that you don't have previously you had control over which version you can call as an API call. Is right now you just call to one Gemini. And so you don't have that control. So you could end up with something like that. And that's something to keep in mind. And then at the end, you need to cost out the whole project. When it comes to LLM, you need to be realistic about the price. All right. And again, you will work on your product. For those of you that are doing LLM, I highly recommend you don't start from the get-go making API calls to test out. First, build everything and then do it around the LLM part, because you automatically will lose lots of money. All right, so just keep that in mind. And if you work with like off the shelves like models that or platforms, they normally don't give you full automation. Right, you need to tweak lots of it. I think the last thing you want to keep in mind is that to have an agile approach to LLM projects or product, you can say that. Break down your tasks. Start with the data ingestion. Okay, we need a pipeline for data ingestion. Then we need basically do feature selection or engineering. Like in case of the LLMs, like your tokenization, types of tokenization that we do, how could we speed it up? How could we stream it? Model selection and evaluation, model deployment and monitoring. And sometimes in teams, you don't need to wait for this to be sequentially. You know, someone in the team works already on some part and the other ones work on a different part, and then you can basically bring all of this and glue them together, right? But you need to be aware of what the other thing is doing. Like that means if someone is working on the feature selection or engineering, like a let's say tokenization, and the other thing, which is model selection, they don't know, they are not talking with each other. They might use a different model, different LLM that requires a totally different tokenization. Right? And then whatever the other team built basically doesn't match. So in general, you want a faster learning cycle, higher model quality, and better chance. It gives you better chance for success. Now, when it comes to cost consideration, you need to assess, should we build or should we buy? And this is like always question, especially if you work as a team lead, you basically need to answer that. We will ask you, right? Can we buy it or should we basically build it? Right, so you need to basically keep that in mind. Buying saves internal efforts, but limits flexibility, and building means that you need to have the domain, or basically it takes time to also build something. Should be open source or proprietary LLM, which we talked about. Should be a first party or third party data. Most of the time, first party data is kind of like a data that you already have, the company is available. And you basically, it's better to use that and use third parties like kind of like outsourcing data only for that part of the data that you're lacking. Let's say your company has really good data, but there's certain category you don't have data over there. So you only try to use third party for getting those data. And then compute requirement. You need to basically keep something in mind. Some LLMs, they require more number of GPUs cluster basically, and some LLM, especially this is more and more LLMs can run on single GPU, or that we have CPU based also. Also recently there's for those of you who want to do LLM, there's a new Gamma model, Gamma N Nano, right? That runs really good on basically on edge devices. So the cost is pretty high. You just need to download it and you have a CPU basically that can run. So that's something to keep in mind. Now, any question on the LLM before we pass? Good.
Not on the LLM, but in the start we talked about human intervention for the data pre-processing and stuff. Like you gave the example of the traffic light?
So that was not for data pre-process. That was, we will talk about it further. That's for data, kind of like a label. Let's say I have a data and I want to see that can you as a human detect it? If all my data are in a way that no one in this class, like if I ask everyone, I get 50% says green, 50% says red. Or even 60% says green, 40% says red. That's not a good thing, right? So you want your data to be in a way that your raters or your labelers or the labels that you have is consistent.
Yeah, you answered the question.
All right. Now, so the next thing is that now this comes more for your scoping. You first need to define something called a user success, okay, or user need. Now, most of the data, like AI model, basically fail because they don't do something that accounts for user need, right? So it's kind of like you build something, but user doesn't necessarily need it. Maybe you build it at school. You need to ask certain questions, and this is called like a human-centered AI. Okay, who are your users? Okay, what are their values? Which problem should you solve for them? How will you solve it? How will you know when you are done? Right. So, as part of the idea, when you try with your team to decide what product you are going to build, you need to figure out who you're targeting, who's your customer. Because again, remember, you're building a product, not a project. That is what you build. You need to come and say that, okay, these are my customer. This is who I'm selling it. Okay, this is the pain point, and I'm going to basically solve it. That's if you have a human-centric view. There's also a technology-centric view, which we're going to talk about. But if it's human-centric view, you need to ask questions like this, so just at least have some answer for those. Now, what we're going to talk about is first, which user problems are AI system uniquely positioned? Like what are the problems that AI could solve? What problem should you solve for people with AI, right? Question, anyone want to answer that? What problem you should solve with AI for people?
Making money.
What else? But why making money? Like, why do you think, why making money?
So the big companies having LLM to generate money for.
So let me rephrase it. This is not for companies, for people.
To solve repetitive problem.
Yeah, maybe tasks that they are repetitive, right? For example, if someone is enjoying the task, if an artist is enjoying making art, you shouldn't use AI to make the art and then basically try to basically sell it more than that. Right? If people are enjoying a task, you basically shouldn't use AI to replace it. You use AI for tasks that is repetitive, cumbersome, or something like it. I don't want to do it. I wish this, like when you're at work, you're like, I wish we could automate this. All right. So that should be a question or basically things that you tackle. How we can augment human capability versus automating tasks. Again, augmentation could be if I'm trying to grade papers, instead of me reading all of it, augmentation could be like it helps me by pointing that, okay, this part, so the important like a punchlines should just read this. Automation will be like, I upload the document and I'm like, I've just summarize that for me because I don't want it. I'm just going to use that summary. I'm not going to read it. I was going to like have that idea. And why this question matters, because they help you to shape your product. It's kind of like the core value of what you are building. Augmentation versus automation. Now, the other thing is that you need to also work on basically user experience. So like how can we ensure that we improve the user experience? Like, the last thing you want is that the user, it's basically you're already doing something and you think you are going to improve it, but you just make it worse. But they don't like the user experience basically goes down. All right, so you don't want to do something like that. Now, let's just start here. So this is what we were talking about. You need to find a balance between people first approach or technology first approach. People first approach is you identify a problem for that is like it has a specific user target. You say, I'm going to solve it for this group. You're going to help this group. Like when you work in healthcare, let's say you're building a device for a certain cohort. You have that people first approach. On the other end, technology first approach, it's that you come up with an idea which is for innovation. Right? It's not specifically for a user. It's like let's say you basically working these days, lots of companies working on code generation, right? That's not basically user-based approach, just a technology-based approach. You want to be sure that this technology can solve certain problems, so that basically that product enhance that user experience, right? Now, both of them are valid. You can have actually like a product that has both view, right? But it could also be just simply one versus the other one also. Now, does AI add a unique value? Okay. I think that one of the first questions that you need to always ask when you want to, or when you're given a product and you're told that, hey, we want to solve this, come up with an scoping, is that, well, do we need AI for it? Do I need machine learning for it? Right? Could I simply have some sort of like a rule-based system that solves the problem? Lots of time, like especially if you are doing a form filling, like it's kind of like based on the conversation, you could just simply do a regex, reduce the cost, and just fill out the form. It could be just rule-based extraction. Can AI meaningfully enhance the solution? Like what types of AI is most appropriate? Will AI degrade the experience in a way? Like that means that, let's say you have already customers, they're coming on the platform and your platform doesn't have AI, but the customers are happy. The process is slow, but you never got negative feedback. You try to optimize this and you add AI and make it like fancier, cooler, but then all of a sudden you keep getting thumbs down. User is unhappy because they're kind of like, despite the fact that you maybe automate the process or improve the process, but you did not actually enhance the user experience. Right? You cause some disruption over there. So the goal here is that you want to ensure that in high value tasks that they don't do disruption by doing automation, because that causes frustration in your users. Now, the next thing that you need to consider is, okay, what are the states? Right? So like think about this, you're solving a problem. Some situation they have a high cost. If you make an error, some situation they're like fine. Some situation they need a really good accuracy. Like user uses your platform for the accuracy of the platform. Some like a situation or some solution the user uses because it's like an idea is cool, like it has some generation around it, right? Like if you work with, for example, like if you work with ChatGPT, you ask question, you want correct answer, but how you get that answer doesn't matter for you, right? It's kind of like it could give you as a table, it could give you as a free text, you would say that, do you want me to draw a diagram for you? Any way that basically could give you the answer that should be enough. But if you're working in finance and someone upload the document and say that should we invest or not, there's like lots of money on the table. You want to be sure that you are precise and there are reasons behind that decision, but not just it's just every time you get the finance service. So you need to understand that what's at the stack. Is it accuracy and precision, or just creativity and basically comprehensive? Now, the next thing is that you need to understand the user expectation. Okay, so it's a concept of user context. Let's make one example. How often have you gone on? I'll give you two examples because sometimes I don't get the first answer. It happens to me, but how often you have gone on Spotify and it offers you a music that you never listen to the genre. Like if you go down, it basically tells you that, hey, listen to this new singer. It happens because what they do is that they want to promote, it's kind of like based on similarity, it gives you something. Or if you go on Uber and you Uber Eat and you select healthy food, right? You get McDonald's. Lots of the healthy food, you get all sort of burgers come as healthy food, right? Why? Because the companies who do that like they put the product, they put that as a healthy. They say that this is a healthy food, right? So it's not Uber's job to detect if something is healthy or not. But from a user perspective, from your content, like your view, how do you perceive that?
No,
you think that the model is wrong, right? You're like, this guys can't even build a good model. But, and that's basically, that's user context, right? So we have this concept error that is where user thinks the model is making a mistake, but model is actually doing what it was trained to do. Because the model was trained to promote based on this. And whatever comes into the model, like that, if the McDonald's has labeled the food as healthy or not, is not the model's basically error. Or if my Spotify once in a while it gives me jazz music, I never listen to jazz music. It's technically maybe not the model problem, it's just maybe the business model that they have for promotion or promoting a new artist, right? So those are things that basically to understand it. And then the next thing is that the cost. Well, in the AI solution will could be costly. There are lots of them, it requires lots of energy and basically manpower or like an engineer's power. That basically that you need to work on that. And then the thing is that most of the time companies don't know how much is the cost. The estimate is pretty low. And then you go into a project and you work on it for a certain time, and they're like, okay, we need to unplug this because it's getting too costly. There's a statistic, I think it's kind of like an older from a year and a half ago by Gartner also. 88 to 90% of the data science projects, they never come out of the lab. Companies build because you have teams, you're like, you want to do something cool, they just work on it. And then at the end, you're like, okay, we built something, it's gone. Like you as data scientist or engineer who work on it, you're like, I built something, I don't know where it is. All right. So that happens a lot. And lots of time also, even in research companies. When I was a student, I worked at Philips, and this awesome project that we work on is like, I don't know, like it was occupancy counting with hue lights. This hue lights that Philips has some signal. You use that to count how many people are in the room so you can dim the lights. And I was really excited. I was doing my PhD, and then we did a patent on that. And that was it. And later I asked them, why did we do that? So that was it. It's like, we have the patent on it now. We're not going to use it. Now it's what is ours. All right. So lots of time companies, they do things like that. You just build something and then it's gone. So that's something also to just keep in mind. Don't get disappointed if you work on something, but you never saw the product. So now, you also want to be sure that you understand the nature of the problem. What does that mean? You need to basically define, it's like a problem that you are trying to solve. Be sure that you understand it. Okay, this is what we are solving. If it's vague, it's not a good definition. I have sat on a meeting, to be honest, I thought I know the problem. And when we talked with some sales engineers, I was like, guys, can you answer these questions? Like our definition of answer was really different from the sales engineer's definition. And we thought that we have everything in place. All right, so you need to be sure that you have a clear definition of the problem, what we are trying to solve, what's the expectation with it. You need to basically validate your framing with kind of like a diverse user. Diverse user means that they don't just target certain, let's say you're trying to do a survey and want to use that survey for building something. And the survey that you are selling is only to certain demographic. But your goal is that to sell whatever you're building as product for everyone. All right, so that's not going to be a good user experience. Now, interview extreme users to understand the perspective, especially. Probe for unknowns. Consider how the problem may evolve with AI, or how the loop should be basically. So things that you need to ask, and there are more than this. It's not just what we see here. Now, on the other end, one thing that's really important is to understand that everyone received the, and situation in a different way. We understand it in a different way. I perceive it. Maybe you say something, and then the AI basically gives you an answer, and you're like, your understanding on that is really different from another, right? If one engineer asks a question from a GPT versus a normal person with an engineering background asks a question, they might think of the answer differently. Right? Because especially all of us, we know that if it gives you an answer, you need to validate, even if it sounds really true, right? You know how to prompt it to say that, okay, cite the answer, all the answers that you're providing. Whereas a user that doesn't have that knowledge, they basically just ask a question and maybe they believe it, right? So try to consider all the socioeconomic status, language, locations, gender, gather feedback, like important points, and identify the sub problems that AI must solve. Sometimes you basically have one idea in mind, but that along the way you also able to solve some additional basically sub problems. Those are things that I also keep in mind. Like maybe a company builds a new LLM, and this LLM for a certain task, and there's a term for it. It's called emerging capabilities, right? Emerging capabilities was the idea came up with LLMs. The idea was that you build an LLM, and then LLM was trained for certain things, and all of a sudden we noticed that they actually have additional capabilities that we weren't training those. That becomes the emerging capabilities. Now, you also need to understand the system perspective. Okay, I think I forgot the name of the interview that I watched, but I think it's from Anthropic. If I'm not wrong. They're talking about the agentic thing, that is like the context of the agent is really important. Basically, in order to see that if the agent is doing a correct job, whatever context that goes to the agent, they pass it to other engineers and try to get exact answer to see that if our engineers can solve it. And that basically consider like the overall the context for the AI that we have. Now, let's look at an example here. So you have a platform, and a user comes and they have an image. And basically, they want to do some sort of image classification. They upload an image. So the first thing that comes to your mind is that, okay, I need a model that can detect the plants within the image, right? So you need to be able to first detect plants. And the goal is that maybe to separate plants from each other. Like it's kind of like the one that are matching with the expectation versus the one that doesn't. And then your AI basically after finding need to do some sort of like a search and say that, okay, I found this plant, let me search about this plant and gather some information. Now let's say user now wants different question. Basically, user says that, okay, I have a different question in mind. So first one was the image detection, right? And the next object detection or classification. And next one, the user says that, okay, is this plant toxic for my cat? Right? So you see that it started with one task. Now they're using it for different tasks, right? So it's kind of like these capabilities that you need to keep in mind. But in general, you need to be sure that you understand the nature of problem and ask these questions. How pervasive is the problem? Who does it affect? How does the problem affect various individuals and so on? So for your scoping submission, there is a document that we will go over. You're going to receive this basically a sheet that you need to fill for what you are basically working and answer a series of questions depending on what you are basically trying to build. Okay, so now the next thing that you need to keep in mind is that, okay, how people frame this problem. Okay. If you have a problem, some people solve it creative, some people solve it really like an engineering mind, and some people might have them solve, right? So people address the problems differently. You need to also understand that. So you basically need to understand the user expectation for what it means for the problem to be solved, right? So and again, that's the question. If you ask an AI these days, when you ask a ChatGPT or whatever you're using, Gemini, and you ask a question, and it gives you an answer, that it gives you the answer, but are you satisfied? Does this mean that you're good? Like, what does it mean for you to be said, okay, I got the answer, right? So that's a question that to understand. Like, if I give you answer, if I give you answer to this user, is that answer enough? Are they gonna like it or not? So you need to basically define the success criteria for your AI system. And how do you define success, right? We built something and we make prediction and user is basically using it, but that doesn't mean success. Right? So you need to define the success criteria. Like if you have an LLM, let's say, for example, for those of you that are doing LLM is that if user keep repeating the question, that means they are not liking the answer that they get. They're still using the platform, they're on the platform. But if they repeat the same question over and over, that means they don't like the answer generated, right? Or if they give you a thumbs down, right? That means they don't like the answer, but they still might use their platform, right? So having a user on the platform shouldn't be it's like a success criteria maybe for you, because again, maybe that's the only option that they have, or that's the cheapest option. But is it giving you the best result or not? That's not always the case. Now, the next thing is a specification alignment. Okay, so user expressly goes through something called a specification. Now, a specification alignment basically is your goal to be sure that your AI can be guided to deliver certain things. Now, what we want to basically our AI to deliver. You want to be sure that your AI doesn't have a poor performance for what user expects. So that's the definition of misalignment, right? And probably you have heard the term alignment, right? In the special stage, right? So basically, the idea is that AI provides the answer. How could we align it to what user wants? Like the goal that user. Compromise safety. You don't want that the AI to be generates an answer and just compromise safety. So you need to have this basic test with it. Reward happy. That's did you see the new article on OpenAI about why ChatGPT or GPT model hallucinates? They released it like a month ago, almost 2 years ago. What was that?
Illusion of thinking.
I think it's that one. It's go take a look at that. Just read the summary by OpenAI team. It's basically they claiming that it's the reward model that model has causes it's basically generates the definition of hallucination. The way that it's rewarded is just it wants to come up with new ideas because it thinks that if I do that, I get better reward, right? So that causes that basically over time to keep generating new things that maybe they're not real, basically. So now, when it comes to framing, you need to have 4 key dimensions. Primary goal: what does the user wants to AI to accomplish? That's your primary goal. Then what's the sub goal? What dependency or side task must be solved along the way? Right, so if user wants for you to do this, there's also like maybe we can call them like an agent task, like all the smaller subtasks that you have, you need to solve. Under a specification, what assumed knowledge is left out? When you built this, you had some assumptions about something and you missed something. Optimization of one sub goal harms or hurts basically the other one. You know, those are things that could happen. Could the AI learn harmful behaviors from those trade-offs that we have? All right, so those are things that just keep in mind. Not that you need everything for your product, but at least some of these. Now, be sure that you design it for dimension of identities. That means design it for everybody, right? Not just only certain users. You know, the reality is that AI or ML basically they will have uneven performance. You know, it's could be because of the data that you have. Your data, you don't have enough data for certain demographic. Automatically, your model is kind of like a bias toward the majority. But you also want to be sure that even if you have if you have bias in your data or data that's basically imbalanced, if you put too much emphasis on the lower like a minority, it's easily can also hurt the majority. Right, so you need to be sure that to account for the minority, but also keep in mind the majority, so you don't want to hurt them. There are some metrics or basically tests that you can use, like a BBQ, Vino bias, to sort for bias detection. And then also remember something that bias could be subtle, systematic, and could be unnoticeable, okay, and contextual. So we have a really interesting paper on this one. I think it comes either today or next class. I think it's today class. There's a bias paper that just reviewed. Now, inclusive design, diverse perspective. So when you want to build something, and especially if it's kind of like with AI generative types of models, you need to get different basic ideas, different opinions, right? One of the teams, I'm not going to name, asked me a question today. I'm not putting you on the spot, I don't even know what it is. They want to build something about idea of like how to rate performance or how to rate creativity, right? The idea is great, but you see that if you don't have a broader view of what's the creativity, you only put your own view of creativity in the system. And you build that system that only thinks of creativity with respect to your view. And it doesn't work for everyone. So these types of models, you need to basically ensure that you either, if you want to build it, you do some, I don't know, like create a survey and collect some data to understand the definition. Or you need to basically have a definition for user. I'm only selling this to I'm targeting this cohort, targeting this user. It's not for everyone. All right. Lots of time in the startups, you could sell that. I built this product only for a small organization. And even if like your product is great, right? And large or medium organization, they come to you and say, well, we will buy it. You're like, I'm not selling it. Why? Because I haven't built it for you. I know if I give it to you, it will break or something because I haven't had time to build it, maybe in the future. And then my basically reputation goes down. So you just target a certain cohort or certain business model, or you can just work with this. Now, when it comes to generative AI, we know that the result that we have is unpredictable. Right, so it's kind of like lots of time you can assume what you can get, especially, but every time you could get a different result. Did you? I keep saying papers, but you can maybe you haven't read, but you can find those. The Thinking Lab research. They published a new paper. Also, this is 3 weeks ago, about why LLM does not generate same answer, even if you put temperature to 0. Right? Go search for that one. That's a really, it's not a large paper, a really long paper. It's kind of like a couple of pages. Read that. The idea is like, okay, if you even put the temperature on 0, you always get a different answer. And why is that the case? If you know, and what they did as part of the study is that it's about the floating point. You know, it's about the floating point of the numbers that causes these issues. So basically, they said that they brought like a simple example. They put A plus B plus C, and this is not equal to on the GPU, right? So, and this comes about the base that the number's on. So the way that it's being truncated, and it's really interesting, really. And that's basically the claim is that this causes that LLMs to always generate different answers, even if the temperature is 0. So the generative AI outcome becomes unpredictable. To some extent, maybe you can expect the answer, but you always have variation on it. But when it comes to generative AI, you need to account for certain dimensions. You need to be sure that you account for age, disabilities, education, literacy, things like that. Location, basically geographics, culture, ethnicity, physical attributes. It's kind of like you need to have a broader picture. It's really easy for companies to build something and being judged by it, right? It happens. Like company builds something and all of a sudden you see all over the LinkedIn, someone took a picture, a snapshot. Look what this I don't know model LLM generated. It's racist, or this LLM is something like that, right? It's like the context is missing, but if you don't account for everything, you can easily be blamed for what you build. Now, again, this just a guiding questions is that you need to understand people's currently frame basically the problem. So ask certain questions and just go over this, like the same thing that we just talked about. Now, when it comes to traditional AI or like a ML basically types of model that you do for classification regression, those types of model are basically you can use them for things like automation, like optimization, like class detection or dynamic contents recommendation. Those are like that's where you use this classical model. Actually, I forgot his name, a professor from Stanford, at the conference that I was last week, he came and he claimed, I don't know the name of his company, but if you search, you basically find they claimed that they built the first LLM for classical machine learning. That means LLM that's not for generating text, is just you can pass a data to it, like a tabular data, for demand prediction, for anomaly detection, and things like that. It's not open source. I think they have their own startup, but that's the claim that they have. So we need to wait for the paper to come out. This is the reality of the thing. But that's something also that right now we call this as classical machine learning. It's possible in the future. You know, we have these types of the smaller models that they can basically do tasks like that also. But on the other end, when you go to generative AI or LLM, diffusion, these types of frontier models, basically, they are good for use cases that reduce the user fatigue. They produce dynamic response, answer context-sensitive questions, augment user creativity, and things like that. So you want to, when you try to decide what I want to work on, have some idea of like, do I need LLM for this? Do I need, I don't know, generative AI? Or do I need to just do classical machine learning? Right, so it's kind of like so I think in one of the groups that I talked with today, they are doing deep learning first. The idea is not the pipeline that you're going to have, the product that you have is not going to be LLMs, which is perfect. So I highly recommend you. I don't think that because AI is in the market, we should do LLM. This class is about building the entire pipeline, not just using the AI or LLM. Okay, so now also you can use also a rule-based system. So anyone here wants to tell us where do you think you should use rule-based systems?
Where there is not enough data.
That could be.
The corporate learning.
But rule-based, like a kind of like a hierarchical system. But where? Not reinforcement learning is a domain. Like what application would you use?
Engagement.
Why gaming? So rule-based system doesn't mean a reinforcement learning. Rule-based system could be like a hierarchical, like let's say it's like a decision tree, random forest. But why? Why you should use?
Insurance learning.
I think you need to tell me also why you need to use that. I mean, where do you think you will use rule-based?
When there's like unstructured.
Like where it should be open, like this is why because we are picking this, so where it's very clear.
You mean to explainability?
Yeah, explain.
What else?
I know when like there's unstructured data where you can't learn anything, and if humans have to set like explicit rules, and if the users have really limited, and we can keep a rule system.
Maybe places where there is a strict policies around the data.
Like what type of process? Like a usage of the data?
No, not the usage, like a certain thing has to happen a certain way, for example. Maybe where there are some.
But in this scenario like that, you actually could use AI if there's a contextual knowledge that if you go do this, AI could maybe do it better.
So, for a mission that would be met, in order to, classify, for example, when we have like a credit risk, right? You need to have, if a person meets certain, criteria, then on the basis of that, you issue a credit card.
Yeah, I mean, these are all correct use cases. Some of this, they're not specifically. But normally when you use rule-based, you have goals. One is that interpretability. You want to know why this decision made. That's why you have those rule-based like decision. Or where the decision is really important. Like in healthcare, lots of time, like even right now, if you go to, if you have someone doctor you talk with, they have these decision trees for certain things that they literally look at it and say, that, okay, this is the answer. Why? Because there's a high stack. And also it's kind of like you want to know if you say someone that you will have like a cancer and you make a decision, why that decision was made, right? So basically you have this trajectory, and then also you don't want to miss something. Whereas if you use just AI or something like a kind of like a black box concept, and then you make a decision and you can't explain it, then that won't be acceptable, right? So it's kind of like lots of time actually in medical journals, they don't publish papers that is using the concept of black box modeling. It should be a statistical decision making. It's like, well, if you use a model, you need to explain, like you need to have a really good statistical explainability around why this model accuracy is like that, why decision making. So now when it comes to generative model, it's really good for open-ended creative question. Like someone wants to generate an image, it's like it's kind of like open-ended. I want something like this. It's not really specific, right? The benefit of that is that user interacts with via a natural language instead of like a rule-based or and maybe you have fixed criteria. It basically makes your UI or basically your interface less predictive, because user can enter anything basically, but it makes it also like a more flexible, right? So that's a benefit, because if you have a fixed interface, the user always need to upload something. It's kind of like a fix, but is less flexible for user. Here you make it more flexible for the user, but it's basically less predictable for engineering side. You can have all sorts of issues. So, all right, let's take a short break, and then we continue from there. So I think the problem was that you saw what they switched it, which number, and switched it back. I think the best possible the Zoom access tool. I'll you can do the recording from this class. Okay. Now, okay, no, that's what I did on the Zoom for activity. You would have access to it. The reason I brought it is it's not the class is not biased. Okay, it's not so like we open it. Lots of students wanted to attend on and it doesn't give us the policy. So the reason we have access all the recordings you can discuss right now here. On the Zoom. No, when you put your son out, because he was kidding. It's a class. People don't attend. It's from this. So you can basically watch the video. Oh, you just put in class in this class. So, I don't even know how many students are asking that question. Yeah. Then, Adam drop. It's not. We have 160.
I think it's really I don't know. No, project with.
You know, seven, I would say yes, because about seven, I need to say.
Yeah.
There was the previous class, so let's see, today class, how much. Now you can see.
Why? Sorry, not why, how? अरे हुआ क्या अब?
अरे ये बहुत अजीब सोता है मैं अनकंफर्टेबल हो जाता हूँ
Oh, so you don't get access to things.
आज हाथ टेम्पलेट हुआ है
मैं इसलिए बोल रहा था कि अपना प्रोजेक्ट करते स्वाद आता
हेलुसिनेट हो जाता है
That's all. So if you say something, we think that comes to you for project idea. I'm not gonna tell you, do we do not, because I don't want to bias. And I'm not gonna tell you people right now, but just idea.
Seriously, the idea is to make us out. For example, we have to ask people to use this one. The risk of running the outside from people in the market. So that's.
Other side, isn't this? I wanna build this. So is basically so lots of them companies. Like a broader question. That's this is I've heard it from other people. Oh, yeah.
So, correct. And how we can get better is so
Challenge you were there. You get access. So. Here are slide farm, get the obvious. Email, summarize and things like that. Yep. Almost like you have. Everybody using it. Yeah. You get every direction. The cell. That's my advice. I hope I can see that. Okay, we have this new tool also. You need an MC. With every individual. With one. It's not much difference. You tell your folks. Even MC, but you don't get to write that. Not that you should realize. I just. Out inside, which if it's real, he's something. You need to get outside. You need to take why would you go? So why would you build for I have a. Yeah. So now I just this different it's not as much easier to get. So in my website, today, and you read the records and basically logging in. That login tomorrow is gone. It's a short period. Every time you don't do that. It's all like, but you think it's still the ancient Allen, why do you think fraud? Also, you usually say that you have lines to strike price. But you figure out between these two. Exactly. You know, It's all. And I excel. Okay, we can always talk about it. Let me ask what the only thing also. Maybe somebody. Three times. That is another.
Whole initial plan was summarizing.
I don't want to buy a seat. So that's a question. But they can charge on a practical enough.
That has three products. One is relax, with bugs. इन लोग का I think इतना different नहीं होगा second person. Data ecosystem.
Smart target companies will buy our product and then they will integrate in the system.
That will
We can get studies based on which companies using.
Yeah, that's what he said. The number of percentage of what platforms has been used all over the world.
That's why either we see but building connectors for every application is different.
Assuming that we are having, so first of all, we have to use partnerships for, so when we having the very high stock data, we need to map it to our method. That's the difference.
I mean, see, there has to be, because
Second thing I
सेम सी कोई भी कंपनी ले मैंने अपनी कंपनी का फ्लोर देखा है एक कंपनी अगर 50 डेटाबेस के साथ कनेक्ट करती है ठीक है वो 50 अलग अलग कोड नहीं लिखती राइट
and the mapper of.
एग्जैक्टली वही
And second point is,
It's possible. Right? It's not like
They say at that point it's not possible. Have a clear explanation of why it is not possible.
like 50 company आ गई, 100 company आ गई, 100 different connections of 100. And then your code will be like, I don't know.
This is an infinite number of applications. Companies are using.
And secondly,
का तो एक ही सिस्टम है ना
That is different होगा.
Buffer types are connected.
So the point is asking us to come up with a route map. Then which time will you which one?
and then secondly, learning is assuming कि 90% कल उसके inbuilt उसने feature डाल दिया कि okay now we'll summarize every time. तो learning की
what about connection ज्यादा होंगे but it's sort of navigate in the way कि connectors हम लोग ऐसा इसको ऐसा बना सकते हैं कि connectors तो आएंगे but market in a way वो आने के बाद
see.
Sometimes
Hold on, I'll give you a better example. The exact same thing I'm gonna use your words. When I asked you about Zapier, it was like, यार इतने सारे connections हो गए कि it's now clubbed. You said that. When I asked you, okay, Zapier करता है.
they provide so many connections which one we want to charge to
Exactly. So even they provide so many connections, right? So basically, it's still cluttered for them when they were working on it, and I was like, okay, I'm going through it. Monday की मेरी list में 100 चीज़ है, and I was like, okay, now I'm searching for it. Now I need to see okay कैसे connections करते हैं. So, समझ आ रहा है what I'm saying? Because every connection can't be connected बना दिया, but there might be a possibility because we don't know how data is gonna be. में what बनाना पड़ेगा, for example Discord, but दूसरे में API connections API की provide करना पड़ेगा. Connections are different, but we and same MCQ.
जगह क्या What else? Do you know what you want to ask? I'm dead. Yeah, I noticed you're late. Sorry. My eyes were so. Let's talk after. Yeah. Sure. Yeah. All right. Okay, class, let's start. So let's continue with the scoping. Actually, there were so many nice ideas that some teams they brought here. And I think that's why the understanding the scoping is really good. And one thing that every team that asked me a question they had in mind was they had an engineering focus on this. Right? The idea for you is that to put two different hats on. You are all engineer, correct? But put the business hat on. What I'm building as a business plan, like want to build something to sell as a product, then think about the engineering concept. Or I just told to one of the teams, maybe split the team in 3 business ideas, 3 people that focus on business ideas, 3 people that do engineering. Go do a separate search, don't bias each other, and then come back and I'll present your ideas to each other and see which way it goes. Okay? If you just try to solve engineering problems, you will forget about the main question for this class, that you want to build a product that can work, that can sell, target audience, right? Not that to just build an AI, that works. That's not the goal here for you. Okay, so now we want to wrap up slowly the scoping concept. How to map basically workflows for your AI, because AI can learn opportunities, right? So you want to basically be able to do this mapping. So you first need to understand the current process, and that comes around what you are trying to do. If you are trying to, so I always say that like if you want to build something, you always build something niche, something doesn't exist, it's your idea, or you pick something that someone else has built, already built. You say that I know there's a problem, I'm going to improve it, or I'm going to make it cheaper. That's how you enter to the market, right? So you either make it better or cheaper. If you just build the same thing, then someone is already in the market, then you don't have any advantage, right? So when you want to, let's say you want to improve something, or someone has already built something, there's an idea, it already exists, and you want to build upon that. The first thing that you need to do as part of your processing, basically scoping document, if you do this approach, is to draw a diagram of current process, how this is being done currently. Because you want to understand fully, this solution is already there, and it's done in this manner. These are the steps that we need to take. And along this way, along this process path, I'm going to fix this part of the process. All right. Not the entire of it, just this section of the process, because I know this is the bottleneck and I know I can make it cheaper or better or faster. Okay. So that becomes understanding the current process. Now, investigate the adjacent products. Basically understand that how user interact with similar AI or non-AI tools. It's kind of like getting some sense of your users. Then prototyping and validating, early. Always remember to basically try to iterate fast and validate fast. There are some tools out there like Wizard of Oz or Google AI Studio. They're really good for these types of prototyping and validation. And then if there is a way that for you to get real feedbacks basically from user, collect that in your pipeline. That means if you can, maybe you start simple by thumbs up, thumbs down, it's a feedback, or have maybe a section that user can provide you feedback. Most of the time, user doesn't provide you feedback like that. If user gives you feedback, it's always the best thing because that's a clean data. They don't like, you like it or they don't like it. But you sometimes also could infer from users' interaction if they like the answer or not. So you can basically, we will talk about that later. Now, and then you want to basically map the existing workflow. So just be sure that you look at the current workflow and we see that, okay, how I want to basically automate this. Look at the basically users and then the features or basically all this misalignment and expectations. Be sure that if there's a pain point, that if you have talked with some users and they maybe like, I don't know, if you think about it, let's say you work on a certain program and you like it, but you're like, I always wish this part was better. Like you hear that in the industry or you see on LinkedIn, people keep posting about this. Right? There's a problem with this. There's a problem with this. Maybe you can go just work on something like that. So, and the last thing, and the last one, even failed attempts or misuse may reveal valuable signals. That's really important. Always keep in mind is that sometimes you get some answers that you're like, this just should be an abnormal data anomaly. But sometimes that misuse basically tells you something else. It tells you some maybe there's a new cohort of the users that you have, or new expectation user wishes that you have, right? So that could be a really valuable signal. Then try to find similarity and variation in tasks. Maybe there are certain tasks that they can be clustered together. Instead of you solving individual tasks, you find a cluster of tasks that we could be solved by this problem, this solution that you have. So it's kind of like it doesn't need to be just a standalone solution. And then finally, I think it's one more map points of decision and feedbacks. Okay, so let's say you have some decisions, okay, and then you want to have some feedbacks on those. Users will give you different feedbacks, okay, and different basically they have different point of view. Okay, so you basically account for this. One of the teams here, I think they were like, if they're here or not, they are going to do something like in fintech, but some sort of automation for what's called like analysts to improve the speed of the process, right? And one of the questions that they had was that is if I make this decision, speed up this process for the analyst, right? But I noticed that like based on some data, that the analyst does the process in a different way. Okay. And should I, when I give them the answer, should I collect some feedback to see if they like the way that I provide the answer or not, right? Or is that just too much noise for my pipeline? And I think personally, like to collect as much feedback that you can. It gives you some strong signal, right? And the other thing is that when you collect those feedbacks, this gives you some sort of like an opportunity for additional invention, things that you don't know that's needed. Like user comes and says, okay, I like this, but it would be nice if you had this also, or if you do this also. Could you add this functionality? And depending on if you work in a startup or larger organization, that also could be a pain point because you can easily be dragged to all sorts of directions. Maybe you can look across all the recommendation or requests that you have and find the one that's common, like the most valuable. Okay. Now, critical moments and failure in the journey. Well, identify where a user interacts directly with AI capabilities. Open-ended interaction need extra design curve. What does that mean? Anyone can tell us. Second one, open-ended interaction need extra curve. What do you think? How do you read that?
Is it like A/B testing?
Right. Yeah.
Okay, what is it that they can add or like insert to the, in terms of, for example, large language model, what type of files they can add?
Yeah, okay.
Where we don't have any control on what the user is entering into the system.
Yes. So open-ended interaction is that when you're dealing with a scenario, like when you work with, I don't know, like a Gemini, ChatGPT, stuff like that. User basically can ask anything, right? And then that's where basically you kind of like the interactions kind of open. So you need to basically ensure that you also control that, right? Like probably alignment or probably like a guardrails over there, right? Now, document error user will tolerate, and there are some users they don't, right? So some of the users that they see an error, so we will talk about this, but you have different types of error. We have something called silent error, right? Which is a type of error that user won't notice. Okay, it could be also silent to you, but it's also possible that you in your system is flagged, but user didn't notice it. Right? There are types of error that user notice it because the way that when they notice it, you can see that they re-ask the question, basically, or they try to align your capability. But there are also users that when they notice that they like, you can see from the next line what they wrote is kind of like angry. Right. So basically user would perceive that or answer to this tolerate those errors differently. Or they open a ticket for your company that your AI doesn't work or that your ML doesn't work just by one error. We will talk about those, how to define success for your users and how to make people understand how to interact with your product later. Basically, that means the last line, this will inform which failures are acceptable, recoverable, or unacceptable. Now, okay, so that's the idea of the scoping. Before we go to data, we want to talk. Go here. We want to ask one like a question from every team. What do you think you need to submit for your scope? What's your idea? Like, what do you think should be submitted as part of your scope?
Show that the project is feasible, like you thought of general pipeline and tools used.
Okay, what else?
Business idea,
Business idea. Okay, that's correct.
system design, data.
Data, architecture, someone said. What else?
Objective.
Objective. Objective, do you mean what? Metrics?
No, the project.
Okay, like a business objective, you mean?
Yeah, no, like the scope of how technical it might get. The technical project.
Technically, all projects also have some business. So you have some business problem, and then you have some ML basically objective.
The cost of analyzing the.
You need to add costs, right? Cost analysis.
But the problem we are trying to solve, and for whom we are solving.
Okay, the basically the cohort user that you are targeting, if especially if it's kind of like a human centered. Evaluation criteria. So if I'm building this is how I'm going to evaluate. What else? Timeline. What else?
Sure that every team member is doing the same thing.
Every team member is doing the same thing. They mean they do the same task or you?
On the same page.
I see. So alignment internally. You need to define an outcome and success criteria. If you're building something like what is the end? Like what point you say we built it? Like what should be the success criteria? Normally, we can basically define something like an MVP, right? So that means that you could build something that does series of things, but you're like, as my MVP, which most valuable basically product would like the viable basically part of the thing that within this time frame, I'm going to build this. And that's what I'm going to deliver. But I have a longer term goal to build this. But right now I will focus on this one and I don't want to diverge from that. That means if you have an idea that you want to build an app that increase the sales, I don't know, for a certain company, for across all the product that they have, maybe instead of right now doing that, maybe you could just pick a category of the product that they have and only do it for that as an MVP. Prove that's kind of like a proof of concept that we can do it, we did it, and then expand it later. Because if you aim really big, you know, it's kind of like you might fall short on deliverable or this getting to that point. Okay, so you all have an idea over for the scoping, and we will you will receive a document around this point. Also, what we want you to submit, but that would be the next step. Is that which you need to as soon as possible finalize your teams. Okay, and again, if you don't have a team, just let us know. The next step is that you need to figure out what you want to work on. When it comes to a scoping, we are flexible. That means you can have an idea now, and maybe a week later you can say that, you know what, we went and we did more search and stuff like that, or we decided to switch the idea, or we couldn't find any data for it, or we don't know how to do it, and stuff like that. You can do that, but nothing beyond a week after the deadline. You cannot come back more than that, because you already will fall behind these schedules. Okay, so just keep that in mind. All right, so that was the idea of a scoping. The next thing we're going to talk about is going to be data iteration. Okay, so remember, we said that most of the time, the majority of your work is around the data pipeline. And the data pipeline is not just in pre, it's also post model also. So that's what we're going to talk about. Now we're going to start with something really interesting: model-centric view and data-centric view. Okay, so there are two definitions here: model-centric view and data-centric view. When we talk about model-centric view on the left, the idea is that you have a fixed data, okay, and then you build better and better model on that data. Where have you seen that? All the research, academy. There's always a scoreboard, right? Data is fixed. Everyone goes downloads the same data. Everyone's built a model over the same data. Everyone try to get a better accuracy than previous one. Go above. That becomes model-centric view. So data is fixed. You iterate over model, make the model stronger, stronger, stronger. Data-centric view, and the other end is what you see in industry, which data is the part that's constantly changing. Right? So you still need a model, right? You need to update your model, but you don't focus on the model per se. You focus on data processes. What you do with this data to make it better for the model. Right? So that's a really different view. So model-centric view versus data-centric. Now, as part of the data iteration is the definition of data augmentation, right? Anyone here tell us what's the data augmentation?
Generate more data from existing data.
That's the definition. So what does generating more data means?
If you have an image for object detection, maybe you tier it or maybe contrast it.
So what's the constraint if you want to generate new data from existing data?
It could be relevant to the topic that we are doing research on.
Relevant. Can you elaborate on the relevant?
Like if I'm building any classifier for dog and that's I will not put humans into that.
But that's not augmentation. Augmentation means that you manipulate the data that you have to build more version of it, basically.
Right, like rotate,
Things like that. But when you augment, What does, like, what's a constraint on the augmentation?
You want it to be as close as to the real world data distribution shift. You want to see like class imbalances or anything. You want to see what the true distribution of data in real world looks like and imitate that for your problem.
That is correct. One thing is still missing. If I augment data, what could be the problem with it if I'm not careful? No. It should be realistic. If you augment the data, and if there's an image and I do something to that image and there was a dog in it, now there's a cat in it. That's a wrong augmentation, right? So one of the first rule of augmentation is that it should be realistic augmentation. It should not change the nature of the data. Okay. Otherwise, yeah, all of what you say basically is correct. Now, let's make an example. So let's say there is like a speech detection basically project you work on, and there are these different noises, like a data point that you have: car noise, plane noise, train noise, machine noise, cafe noise, library noise, and food court noise. So you have data with people that are speaking in this data, and there are different noises in the background. And your goal is that to build an AI model that, with the noise, can still transcribe the basically audio. Okay, so let's say you work on this speech recognition, and then you see something like this as a performance. So for different types of data, you see different, like the blue, basically, you see the blue dots or the green dots. So the blue dots start with the model, the one at the bottom. So that's the performance. Let's say that's accuracy. Now, if you look at the bottom line, ignore the first two, the top ones, just look at the bottom. What could you tell me about what you see? And that's the performance, right? It's kind of like a dot, 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 you connect. If you just look at the bottom line, which is model, for different data space, what do you see as a performance?
We need to improve performance of some sounds, which improve library, cave, and food code.
So what do you see in it?
The performance of those is less compared to remaining sounds.
Okay, what could be the reason?
Data, improper data.
That could be what else?
Data imbalance, overfitting of data.
What's one?
There's speech in those other. Speech recognition.
So these are all correct, but the main thing that you could see is that the type of location, food court noise, cafe noise, library noise, are where people around you are speaking, right? The other ones, basically, they're machine noise, kind of like a machinery, mechanic noise around you. Right? It was easier for the model. Now, the idea here is that, okay, we have a model that performs really good on those categories, does really bad here. Now, how could we improve this as part of the data iteration? Okay, we need to, like one of your friends said, that we add more data to those categories that we are doing bad. But the question here is that, should we add data to all of those? It's costly. Which one would you add data?
Right, those three which are failing.
That could be, but one idea is that look at those three. Cafe noise is the lowest, and augment that one. Why? There's an idea. It's kind of like I think it's man-made idea. It's kind of called a rubber band strategy. So you put the rubber band around the cafe, pull it up. What will happen? It pull this neighbors, right? Pull up neighbors, because they have a similar, basically, similar domain, similar types of noise in the background. So instead of adding maybe data for everything, you figure out which one you are doing the worst on, improve that. And the idea is that by doing that, automatically you improve the other two also, right? So you basically, what you want to learn from here is that when you have data that does really bad on certain things, don't try to add data for all of them at the same time. Pick one, which is the worst, augment that, and see the impact. And then, if necessary, go to the second worst one and try to do that, instead of just at the time, basically in one go to add data for all of them. Now, Again, data augmentation, the goal was to build a realistic examples that your algorithm does poorly on, but humans basically do well. So you basically have this idea and you will say, okay, I'm going to augment this data so my AI can also learn that. It should be always, when you do augmentation, it should always be realistic. X should be always clearly mapped to Y. That means, again, if you flipped an image and then now there's like a sign, for example. If it's a sign, if you flip it, you can't read it. So that's not a good augmentation, right? So you need to be sure that you account for those. And this is an example for image. So you have the image on the left, there's a scratch on it, and you're like, well, I'm going to augment that. So here, in this one, we flipped it, you see? So this, sorry, it's a bit hard to see with it. First, this was a diagonal like this, as a scratch. Now it's like this. This is still a scratch for our task. Here, we've just increased the brightness. But here, we decrease the brightness. We increase the darkness. So now you can see basically the scratch. So that's not a good augmentation. Right? So you want to be sure the augmentation does not hurt the data. When you work on the data iteration, and this similar diagram, you're going to see the entire course for every part. The entire MLOps or whatever, AIOps, what we want to call it, is a loop. It's always a product is a loop. You build something and this loop continues. Like iterate over it and make it better over time. When you come with data, go over the data, it's also the same thing. It's going to be a loop. You add more data, you improve something, you do some training, you do some error analysis, figure out where's the problem, add more data, continue. Right? That is always a loop that's going to be part of your product. Now the question will be that, well, can adding more data hurts the performance, right? What do you think?
It might overfit and then it memorizes the result, and if whenever there is some random data which has been inputted, it cannot give the actual answer just because it overfitted on the data points which we passed in.
What else?
Depends on the data we pass in, the bad data. But
Okay, so these two all work around the data, right?
If you create imbalance, so that will affect the model performance.
Okay, that's also correct. If you change the balance of the data and you don't account it for it as part of your training, that's happened. But what else? What about your model? Does that, which model I'm using, that decision could impact on adding more data or not?
The training time.
The training time increases. It depends, not necessarily. You could have more data, but your model converges really fast. Right? So what if we what if you have a large model? When you have a larger model, basically, that means the type of model that they have low bias. Right? So like a deeper and deeper models. Adding data normally doesn't hurt. Adding more data, because there's enough space for the model basically to learn, right? But when you add, it should be clear. That means the X to Y, whatever you augment, it shouldn't just disrupt the model learn. So if you have a large model that you're using, adding more data, it's not like a rule of thumb 100%, but it's most likely doesn't hurt the model. It helps with improvement. Now, it's just an example of OCR. So OCR basically, it's like when you have text and you want to basically read the image of a text and you want to read it, right? It's kind of like optical character recognition or detection, basically. Now, let's say, and I think this is like a real use case. So you have a model that's what it does. This image processing reads the plate like a house numbers, and it does a really good high accuracy on one. In US, most of the time, the house basically numbers are digits. There are some states that they have letters in house numbers. So the company basically used this data and they did basically this OCR, trained their own model. And then every time there's a one, they basically do a really great thing. But then when they went to states that have I in the house number, they always predicted 1. And they basically what happened was that all the delivery packages basically was going wrong direction. Okay, so what they did, the engineering team was like, okay, what we're going to do, we are going to focus on I, and we're going to augment images for I and basically train. So they augmented lots of image like that on the right. But if you look at this image on the right, you don't know if it's an I or it's a 1, right? So what happened was that the performance of 1 went down, but for performance on I went up. Because now you have more of I, kind of like you end up the model basically overfitted towards I, you know. So it's important again to remember just an example to whatever you do as augmentation to be sure that's valid.
So how do you augment in such situations? Because this seems to be a non-solvable problem, because even if a human says 4 to I or 1, something like that, it's like they wouldn't be able to know if it's a 1 or I until they have context.
That's really valid. So if like maybe if I look at the image, I still also cannot detect it, right? Maybe that's really challenging. Maybe the company shouldn't use the same model for that specific estate that has basically letters in the digits. So maybe you should use a different model. Or maybe you when you augment your data, you need to ensure that the augmentation always looks like an I, like that's form, instead of just a line. So anytime you have an example like this, that you don't know if it's 1 or I, you just drop. You know, it's kind of like a open-end engineering question for you to do. Or maybe you could simply have different models, right? And just do comparison models. So now, when it comes to adding features, you know, it's kind of like a more like a structured data. So in unstructured data augmentation, you generate. In the structure, that's one of the rules. Always remember, you can't generate synthetic data. If you have a table of patients, you can't just randomly create patient and put in between. Lots of time in project, I see students, they use Smooth to create new patients. Like it's kind of like, okay, who's that patient? Like, right? Because that's really important. When you deal with the structured data, you can't just generate rows, right? If it's number, but it doesn't have a meaning. So maybe if you're, I don't know, in e-commerce, yeah, sure, maybe you make a prediction how many shoes they will buy. Maybe you can generate synthetic. But if you're in healthcare or if you're in finance, you're making a really important decision. You can't just generate synthetic data like that. So now, then the question was like, you come to add features. You want to basically add more features. Now let's look at the example. So we work for building a product that's for recommendation system for restaurants. And the problem that you receive from customers is that people complain that there are lots of vegetarians that come on your platform, but they never been offered a proper vegetarian restaurant. They always get recommended with like wherever it sells meat, right? So now maybe your engineering team says that, okay, we're going to add that capabilities. Our data is not unstructured, it's structured. So what should we do? We should add some new features. Maybe features like, is the person vegetarian or not? Maybe we detect that based on the past order, right? Or maybe, does this restaurant has a vegetarian menu? Did you basically do some image processing, some OCR or something over the menu, and you detect that if they have a V sign, you know, so you like, or if you see the vegetarian menu. So, because it might not be on your platform already. So basically you can add that to improve this issue. Now, in general, you need to ensure that if you add more data, even if you add columns, don't add so many at the time. Because that way, if you do error analysis, you don't understand the impact comes from where. So you always basically, if you add a new dimension, maybe add 1 at a time, 2 at a time, do error analysis and then continue. If you add more data, like augmentation, don't all of a sudden augment 5 million records. Maybe I augment like a 5,000 records, 10,000 records, 20,000 records, and see the impact as you adding or augmenting more. So don't go large numbers because it's just become harder for you to understand, was it Am I doing better because I added lots of records, or am I doing better because the data that I have is unique? Or maybe if I only added 100,000 records instead of 5 million, I would have get the same result. Right? I reduced the cost of the entire pipeline. So be sure basically to keep in mind. Now, the other thing is that when we come around the data, so there's a concept called experiment tracking, which we will cover on probably in a couple of weeks. Actually, one of our speakers is comes from the one of the experiment tracking companies. So did we announce the names? Yeah. Okay, so we know. I'm not going to say it as a recording. But so that's a startup. They do experiment tracking. So their platform is something that we're going to learn from. Now, the idea of experiment tracking is, which is applicable in different places, is when you build something, you need to, from get-go, account for series of questions. Questions like, what should I track? Why do we need tracking? Tracking helps you to, when something goes wrong, to understand, trace it back, to understand what went wrong. If something works really good, to understand why it works really good. Or if you have a large team and they're working on different things, if you don't do experiment tracking, they might basically waste time. They work on the same thing exactly. Or even yourself, you work on something and you didn't track it, and months later you're like going back doing the same because you did not track it and you just got ready. So the idea of experiment tracking is that you build this platform for yourself, or you use the existing platform. We will work with multiple of these platforms in the class, but they will track the experiment for you, like what data you use, what tools you use, and stuff like that. Now, when you want to work with them, there's always a question: what should I track? Algorithm, code, and versioning. That's your GitHub basically, right? The code basically versioning that becomes your GitHub. Now, in machine learning, you need to track data set. Which data I used, which version of the data, which date I got this data. Next month I have a new data. What did I add to it? What's the new addition to this data? And that becomes data version control. So you have seen code version control in GitHub. Now, data version control is basically a different definition. There are some platforms that are also free. Like one of them, technically, it's kind of like a equivalent of GitHub. It's called DVC, which all the code that it has, the functions that it has, is like GitHub. Instead of git push, git pull, you do DVC pull, DVC push, everything. But you're versioning the database. That way you can track of, at this point today, I use this data. In a week, we added new features. You create a version of that and a story, basically, so you can track it later. Right? So that data version control becomes really important. The next one is hyperparameters. When you build ML, you do all this hyperparameter tuning. How many of you have done hyperparameter tuning? You use manual tuning or you do automate? How many of you they're doing manual tracking, like you tweak parameters and stuff like that? How often do you track that? Not at all, right? So when you do manual, like hyperparameter tuning, you might even bring a notepad and type in it. But after a while, you forget about it or you just stop doing it. The good thing is that these days you can automate all of this. So basically you use some platforms, or most of these libraries, they have some capabilities that you log those information. So you have them always. Now, on the other hand, when it comes to tracking tools, you could track text files, spreadsheet. And when it comes to desirable features, basically, you can look at the data that they basically replicate, kind of like a result for you. You can do some in-depth analysis. You can just compare the result of today with yesterday and see that, okay, what happened. They have a dashboard, for example, for you to do comparison. You can even compare the experiment between your team members. So for your project, which we will basically talk about, is that when you start experiment tracking, you can have this basically central repository, kind of like a storage, that everyone on their computer, when they work, they save the experiments result on that place. And you always have this unified dashboard that you can look across different users' machine to see that, okay, what's the result, what's the experiment, which direction should we go and stuff like that. Now, another thing about data iteration is that the concept of from big data to good data. So how often have you heard the term big data? Do you guys might be younger than now, like maybe 10 years ago, the idea was that big data era, everyone was just about big data. I'm just kind of like a big data, companies dump all the data in a place, big data. Now it has changed. We do big data with LLM and stuff like that, but it's about good data. All right. So right now, like every company that or every team that they open source the LLM model, they open source the model. They never open source the data. The data is that source, that valuable thing. Right? This is about, it's always about the good data, not big data. Right? There's a term garbage in, garbage out. Right? If you have a pile of garbage, good data, doesn't matter how good is your model, is always going to basically generate garbage. But if you have a smaller amount of good, pile of bad garbage, bad data, you always produce bad data, bad model, bad result. But if you have a small good data, you can always outperform that model that will upon a pile of garbage. That's the idea. So for the definition of good data, you want to be sure that your data covers important cases. It has a good coverage, right? If I'm trying to solve let's say this is like a the space that I'm covering, that I could solve for, and the data that you collected comes from this corner of this. So you don't have a good coverage. You maybe cover only 30% of the population, right? So you not even a population, 30% of the data. Like you have all sort of variation in this data. So you need to have a good coverage. You need to be sure that you have defined consistent. You have a consistent labeling schema, and labeling schema with. Yeah, we're going to get there soon. Is that it's so easy to label data, like pay somebody to label it for you, and later look at the data, it's like, okay, these are all over the place because the definitions are wrong. So you need to have a good definition for the label. And another example for that is that definition of a good label is that if I give you an image of the traffic light and I tell you, what do you see? Just what do you see? You can write anything. You could say, I see a car, I see a traffic light. Whereas I tell you that which color is the traffic light to you. That's a good definition, right? So you need to be really sure that the definition of label or what you're basically asking for is clear. And then just be sure that it has timely feedback from production data and also size it appropriately. Now, why data definition is hard and why we're going to emphasize probably 3 class on data, because it's one of the problems that one of the areas that you are going to work on for a long time. You work on any project or product that you're working, any company that you work, you're always going to work on data and data pipeline. Companies have lots of data. Either that data doesn't have label, someone needs to label it in order to use it, or the data has label and it's not consistent and you need to go over and fix it. And either one, you don't want to do that. You don't want to be that person to doing it. You'll do it. I personally have labeled so many data in my previous company that we were just getting tired of. If someone tells them you need to label data, I'm like, God, no. It's like you literally need to sit hours in front of a computer and try to label data. And because you don't want to also do a bad job because you're the engineer who's working on it. So you want to actually, sometimes you go over, just like over your head. So now think about this. Iguana detection problem, okay? Use bounding boxes to indicate the position of iguanas. Which one of these 3 do you think is correct?
All of them.
All of them are correct. It says use bounding boxes to indicate position of iguanas. Doesn't tell you iguana 1 from iguana 2 or what is the definition of iguana, like a fully. Like you need to define when you say iguanas, am I mean as like an individual iguana, it should be a full picture iguana, or it should be just what if they're overlapping? So if you don't have the definitions and you give data to people, because normally what happens for labeling, you either do in-house labeling, that means like I have a data, I will ask every student, like, you get 10 points if you label it. Right? That's in-house, right? We don't do that, but or the other thing is that you outsource labeling. You pay Amazon or other companies, AWS, like stuff like that. They have something called raters. Basically, you pay these companies that you actually have people that they manually label this, right? So you basically you get charged. They have AI version of it also, but there are like there's certain types of document that you cannot trust AI, so it's manual labeling. In medicine, if you want to label data, especially, so when I was in nutrition, we had this grant to work on a project for liver, basically kind of sort of basic cancers called the NAP or NASH or NAFL. We had this grant to get data from Mass General Hospital, basically to work on, right? And this data need to come from a radiologist. And this data basically need to be labeled by radiologists. That's the only people who can, right? And not one radiologist, comes from like a 7 or something like a radiologist, basically they read it individually and they rate. So there is a cost associated to hiring radiologists to label that data for you, right? And radiologist time is not, it's not cheap. It's considered the highest paid basically medicine job technically, right? But so you pay lots of money and we end up basically getting 112 data points labeled. 112 data, right? So there is a cost for labeling. And if you don't have a precise definition of labeling, what do we want? How do I want it? What's the goal? What's the definition that we have? You could easily waste lots of money and don't get what you want, right? Lots of time for a startup, especially, you have a limited budget and you try to buy data or label data. So you need to be really precise before quickly going finding someone labeling. Work on labeling definitions and try it out. Meet your friends or some people and say, okay, given this, what do you think? Read this carefully. So you need to basically define that. Now, here, for example, phone defect detection. Well, the idea is that you detect the scratches. So you find that, this, or this. All of these three is also correct. Yes.
Going back to the last example. So how do we know that something can be labeled by AI or not? I mean, I understand that there are certain cases when, it's either unethical or there's specific knowledge that's needed. But other than that, how do we know something that can be labeled by AI?
So I think these days there are a couple of checkboxes that you need to review. First question is that can you use that AI platform for data labeling, right? Because lots of time is the companies make it illegal for you to label your own data with them. That's kind of like a knowledge transfer, right? So if you have a data, if you keep making API calls and try to, you first either hit API rate limit, but then also later, if they can probably sue you and say that it's against our policy that you transfer null, because that constitutes knowledge transfer, right? But let's say you don't have that problem. So if I'm trying to label a data which comes from really sensitive domain, healthcare, which I cannot make a mistake, then definitely I cannot use AI. Because if it's just 100 data points and you quickly give it to AI and then later you verify it with doctors, maybe, but you could also bias their opinion, maybe do kind of like a blind blindfold comparison. But if it's like lots of data and you use AI, who's going to verify, right? And there's types of domain that you cannot make mistakes. Or like in stock market, or like a finance, like a purchase versus not purchase. So those are type of things that you probably don't want to use AI for data labeling. Or like these days they're talking about like using multiple LLMs as a judge and as and so on and so on. But when it comes to something like in this image detection, maybe, right? You can probably use AI for creating boundary boxes because it's not impacting anyone. it doesn't have, like, if you detect that as a iguana versus detect that as an iguana, it shouldn't necessarily impact the model accuracy, performance, because it's still doing the correct job. But if you still have a really defined definition, like you want the one on the left, right, the image on the left to be as a correct label, then, and if you want to use AI, probably you need to do few shot examples. So you just provide few shot to the or whatever AI you're using and say that this is the definition. Right. But in summary, I think you can use AI for labeling if there's no high stake, at risk, and or there's no basically policy violation. Probably you can use this.
And then have you heard about this guy who got out of like, just fresh graduate or something, then he got really rich by selling labels in the like meta.
What's the name? Scalia.
How did he do that? Why? What did he offer? Nobody else offered.
I don't know how he did that. To be honest, I'm not sure. But I mean, I think how you need to look at his business model. How did you disrupt the market?
I imagine it just took it to a sweatshop somewhere and had like children do this for him or something.
That's possible. So there are lots of companies out there that you want to go buy data from them for labeling. That's a manual task, and it happens in some other countries. They have like a really cheap labor and basically do labor. Right? It's common. Like even like big companies like used to do something like that.
Amazon.
Yeah.
Right?
And I didn't want to name, but you went. But these days, lots of companies are kind of moving toward AI because it makes it faster. That the process over there was like harder. They try to make it faster to use AI. But I don't know that specific company which product, which approach they did. But I think maybe his business model was really good and cheaper and faster than other companies. Maybe it had a higher performance or accuracy. Or maybe he had a really good, if he used human, maybe he had a really good rules of how to label. One of those rules is that when you want to scope, like do labeling, and you have let's say I have 100 people that you want to label. You basically first do a blind full test, like you give them a labels and say that, okay, label this based on what you think. Then you basically get the data and then you talk among us. Okay, why do you think it's like smaller, for example, smaller scale? Why did you label this? Why do you label that? Kind of like you do something like intervention. And then you give them rules and it says that, okay, given this rule and the knowledge that we talked about, how do you label this? And you compare them. And then you iterate enough with this team that this team become kind of like expert. And you use this team for like a half subordinates, so it's kind of like a smaller groups under them. And they transfer this knowledge, basically. So that could be a practice for doing something like that if you want to. But in general, you need to have either a really good AI system or a really good definition for raters to label that manual. Right? Yeah.
If AI is already able to label the data, then what is the point of again labeling it with AI and training another model with it?
So that's a good question. So let's say I have there's a company that it has an AI model. You give them this data, and this AI model is so expensive or something, and they basically the data goes to them, they label it out, send it back to you after a week. Versus you have a customer that we want a model that's lightweight. That right now, when I click, it can work. And so it's kind of like it's kind of like you send the batch data, it takes a time to come back and stuff like that. And the second one is that you build your own model and it's like much cheaper, for inference for the customer. All right. So, and this scenario also, again, all three is correct. Now, when it comes to, we need to get back to this. When it comes to data, you need to start with definition of your data, establishing a baseline. What is a baseline?
What the human is pursuing, how the human is living.
Okay, what else? Versus how? What else could be baseline? Let's say there's no human.
You take a pre-trained model and just evaluate model performance.
Pre-trained model, okay.
There is no loss in data.
No, baseline.
Baseline is something like starting point of your project, you build upon that.
So where do you get baseline? If you don't have human labeling, where else could you get the baseline?
Is it chance?
Chance.
Like if I have 4 labels, then it's 25%.
If I fill it randomly, what will happen? Right, there could be a baseline. Actually, in one project, we did something similar. We shift the answers because it was about someone like a patient blood pressure is going up or down, and we just shift the answer and compare it with the model output. And the baseline was about 70-something% accurate itself. So that's great. But baseline basically is that, as you say, in the starting point, but where it comes from, baseline could come from human labeler, could come from some sort of like a statistical version, or it could come from other studies. Like everyone else has done this product, there's a paper about it, and you search about it, right? So when if you ask humans to sorry, I talked about from the experience. So one of the projects we work in cybersecurity was PHI detection. PHI means patient data detection. If you read this document, you can tell me this is a patient data, sensitive document or not. Humans, they are 91% accurate of this test. This is released statistic. So we knew that humans can 91% accuracy say that 9% of the time you read the document, you're like, this is so crazy. I don't know if it's about a patient, it's about the story of medical story. Like it's crazy. So our goal was that we wanted to build an AI model to scan documents and can predict this is a PHI or not. Why? Because if it was sensitive, we would have encrypted. So if the hackers basically come and steal the data, they use all the encryption. But we already knew when we started, we need to beat 91% at least. That was the base. So sometimes this baseline is a statistic is out there. You just basically need to search and find, or someone else has done it and they're claiming we reached this number. So you want to compare it. Now, when it comes to label ambiguity, let's say you're doing something more advanced, like you do speech recognition, and you have this basically audio, this nearest gas station. The other one is nearest gas station, and the other one is the nearest gas station. And that unintelligible basically is like whenever you do a transcribe or something you cannot detect, basically replace it with that. Now, any of this basically when you do basically transcript and you ask people to do that for you, they could return any of this version to you, right? So it's like there's ambiguity in these labels. Or when it comes to user ID merge, how many of you know what's user ID merge? Right. So it's one of the biggest challenges in entire industry. Like every company has some sort of user ID merge. User ID merge is especially when you have a multi-platforms. Right? You have platforms that you have different customers. From on your Gmail or basically you have customer come to your website, you do this. How do you detect these are the same people? Right? That's user ID. Especially lots of time, they are missing fields, right? For example, you might have the job board here, and then you have another website, which is a resume, and your company buys maybe data from the other one. And you want to see that, okay, that person is updating their resume, they are on the job board, or maybe vice versa. Should I reach out to them and say, hey, are you looking for a job and stuff like that? But how should I know if they are the same people? Everything is almost look alike, but the address in one is missing. So that's user ID merge. It's kind of like a really big challenge to detect people if they are the same or not. Now, when it comes to data definitions, basically you need to ensure that in this scenario, what is the input? There's like this image, and there's like a scratch on it. You have lighting, you have contrast, resolution. Those are features basically that you can change. But what it needs to be included. So let's say you have this image, and all of a sudden your model performance goes down. Like your model is not able to detect if there's a scratch on the phones or not. And you get complaints from the manufacturing that you're using your product. Hey, we keep this model is stopped, like it's not detecting scratches. And the first thing you could do if you haven't done a proper tracking, is to just blame your engineers. Now we're going to send them fix it, update the model and stuff. Or the other thing is that you tell your engineers, hey, check the trace, check the logs that we have, see what has changed. And you could have data like the lighting contracts and stuff like that. But let's say, for example, your engineers are looking and say, okay, in this specific basically line, one of the lights, like the brightness that we see is low in compared to the rest of them. So you could find simply something that is not part of your pipeline is impacting the models out. Right, so what features you're collecting, you also need to be consistent. Now, there are some major types of data problem. And we start with this easy to memorize basically chart with. You have a small data problem and you have a big data problem. So you either have unstructured or you have a structure. If you have a small amount of data, that means you don't have a large data, you have a small amount of data. If you have unstructured, you basically manually label the data. You have only limited amount of data, right? So just manually do that, ensure that it's correct. If it's structured, basically, you need to focus on ensuring that the data is correct. So when you have a small amount of data, your focus is clean labels. That's more important than any small amount of data because you don't have anything to learn from. So that whatever you have, it should be clean. When you have a large amount of data on the other end, your focus is not on the label that one. You could have noisy label, that's fine. Your focus becomes on data processes. How quickly I can process large amount of data and continue to basically feed into the model. So you kind of like look at the problem here. If you have a small amount of data, put your focus on labeling. If you have a large amount of data, put the focus on process, data process or data pipeline. On the other end, when you work with unstructured data, normally we don't have a large amount of data unless you download from like a text these days from websites. But human can label more data and data augmentation could be really helpful. But when you deal with structured data, well, humans cannot be labeling the data for you. It's kind of like not possible. And it's harder to get more data when you deal with the structure because labeling is not that easy. So this is the same thing we talked about. Now let's go here. Let's look at the small data and label consistency. Look on the left, you have 5 data points. And you are trying to feed a simple linear regression, right? Any of those could happen. Any of those basically regression lines, we see you could feed lines go through. Because you have a small data and it's noisy label. On the center, on the right, sorry, all the way to the right, you have a small amount of data, but clean, consistent, basically labels. So that's where you get a perfect scenario. On the other end, in the middle, you have big data. So when you have big data, because you go through the average of all of this, right? Doesn't matter if there is noise, what you get on average is going to be a good result. So it basically tells you that if you have a small data, what could be the challenge if you have a large data. Now, in the phone district example, on top, we have 8 examples. So we have 8 phones that were asked people to, like a raters, for example, or your engineers to label, is this a scratch or not? And what's the size of the scratch? So you basically see that 0 means it's not a scratch as a label, 1 means it's a scratch. So those are the scratch lengths, and on top basically says it's a scratch. Now, the first thing that comes to mind, if you look at the top graph, where it's labeled, why then the scratch of length 0.3 considered not a scratch, but a scratch of something 2 between 3, the 2 on top, considered as a scratch. You see? So there are inconsistency in the definition of a scratch based on who was labeling it. Some engineer assumes that, okay, less than this number is not a scratch. Someone says, oh, this is small, but the other one says, oh, it's a scratch. So what you basically maybe could do here is that define, or company maybe has a definition. Scratch is anything more than 0.3 millimeter. Anything below that is not considered scratch. So you have this definition in your data definition for your labelers or for your raters to avoid mistakes like that. On the other end, big data has also some, basically, big data also has small data challenges. In big data, this is, think about it like in queries. Majority of time, is it like Anthropic that they do search? Perplexity. So Perplexity released statistics around how people using the platform for search. What do you think they found? Anyone knows that? Majority of time, it seems like a really large percentage of time, people query is like a limited number of words, like up until like 5 words maximum. It's like people do really small, like you type something, query. That's how you don't write something lengthy, right? And how often when you want to search on Google, you basically just type a word and you expect it to detect. That's the problem. So most of the time, in millions, the search basically could be like a really small amount of tokens. Versus, like a kind of like a long tail, someone writes something really dense. So you most of the time for the large data, big data, you have these problems. It's called this, this tail issues basically. It's the skewed data. So now how we can improve label consistency. If you're labeling data for your product, or if you're labeling data at some point, or you hire people to do it for you, you want to be sure that you have multiple people to label the same thing. Normally in an odd group, so you can break time, right? When there is a disagreement between your labels, you give an image to 5 people, and like, let's say 3 says it's a cat, 2 says a dog. You need to figure out why there's a disagreement, right? Is it like a not obvious, this data, right? So it's not just by majority accepting it. You just also understand why the other one cannot label this. If a labeler comes to us that I don't know, I don't see enough information in this data, don't use that data basically. Don't try to force them. No, you need to come up with a decision. All right, so that we just add noise to it. Now, here becomes a definition, like an example. So we have this on top one, which is for speech recognition. You have nearest gas station, nearest gas station. So you basically define an example for labelers, and we say that if you see something like that, just write it in that unified in one style. Don't use kind of like with accent, just maybe just shorten. If you want to detect basically scratches, instead of having deep scratch versus shallow scratch, you just create one group, say this is a scratch together. It's kind of like you try to minimize those dimensions for labeling.
Is that make the problem like the solution works? Like you combining the things because it's still a scratch, right?
If your goal is to just detect a scratch, not to say if it's a shallow scratch versus a deeper scratch, then you don't need that, right? Because your goal is that if it's a scratch that considers a scratch, this is defective. Not if it's a smaller scratch versus large. But if your goal is that to detect a scratch and what type of a scratch, so you still can do this first, and then you have a second model that now categorizes it as a shallow versus deep scratch. So, like another example is that you basically could define as part of your labeling something like an alternative or borderline. Like maybe you don't want to lose some data, and the data that they are not sure, you give them a different labels, like a borderline, scratch or not scratch. Here in this example also we see that nearest go versus nearest grocery. Instead of dropping this example, you basically write nearest unintelligible. So you still have the example, but you just, the word that you are not sure, you basically put some sort of like a placeholder. So, as always, goal is that we, for small data, usually a small number of labelers you need. Be sure that, you know, they can basically openly discuss the ideas. When you work with a large amount of data, you need to have a really good definition with a small group. Then you send the labeling instruction to everyone else. You can do some tests to be sure that they understand the labeling instruction and stuff like that. But again, most of the time you pay for these services, so you need to be really careful. And to before we wrap up soon, come back to the example that we had, the scratch example. So let's say, so here basically we're talking about kind of like a base error or in a reducible basic error. So here what you see on the left, we have ground truth label. That means the label that you have, and so it says 111000. And on the right, you have this inspector or labelers that you pay them. You want to train them, let's say. And you give them and it says that, okay, label this. And you compare their result with the actual answer that you have. When you see something like this, you have 67, almost 60, 67% accuracy matching between ground truths and your inspectors. Now the question should be like, why my inspector cannot label this? Like what's wrong? So what you basically do here is that the first question that you ask is not like, why my inspector cannot answer this? Is the data label that you have correct? Because where did I get that ground truth? Someone labeled it for me, right? Another human has labeled that. So where maybe this ground truth has issues. So basically you go look at both scenarios, look at the ground truth and see that, is this based on the definition that we have correct? And then you basically look at the inspector definition. And then if you swap that, basically, I think we have some slide later, you would reach to 99%, almost 100% accuracy. Because you find one mistake in the ground truth and then one mistake in the instruct. This is just some hypothetical examples. But lots of time the companies have this goal of raising HLP. As we want to go beyond human level performance, we want to outperform that, something like that. Not that it's not good, but it can easily, diverge you from reality or from the focus. So your focus will be one thing. Beating humans in this sport or beating humans in this other game, it's kind of like that, right? So be sure that you also understand that shouldn't be always the goal. You want to be for certain tasks as far with humans, but that shouldn't be your engineering goal to beat that number. Just go above that. It just things something like that. Okay, let's see. Okay, classes slide. Okay, now when it comes to structured data, why we are not using human level performance on structured data? Let's ask questions like this. User ID merging. I give you two resumes and one field is missing. Can you tell me these are the same people? Even if it's 9 out of 10 fields are the same, but the city is missing, or the state is missing, you're like, I don't know. Certain like maybe names, they're really rare. My name is probably really rare if in US you find 2 of this. So it's easy to find. But certain names you cannot, right? So it's kind of like not easy. Based on network traffic, is computer hacked? Ask a human. I was like, how should I know that? It's kind of like maybe if you look at the a traffic of output, you see that okay, if there's lots of data going out, it's suspicious, but maybe they're using some services that need to transfer that much data. Or is this transaction fraudulent? That's human cannot do that. A spam account is a bot. Like that, when you chat with something, it's like, is this a spam? It's like a bot. It's like how should you know that? From GPS, what's the mode of transportation? It's like a person on a foot, on a bike, is it running? Those are types of things that humans we cannot do that, right? Because we can't see that much context. We can't find the patterns in the structured data. Right? So that will be the challenge that we have. All right. So we'll stop here. We didn't have lab today because I missed the last class and I asked VTs to do the multiple labs. But from next class, basically every class, we technically from 7:40, we will have labs on the domain, on the topics that we were talking. So we didn't have for this week, but next week we will have. Next week we have airflow, DVC, and torch data pipeline. So those are the labs. There you go. I personally mixture of Google and Austin. Sort of teams. That was the volume and everything. We can see go over there. I need to like that. On the badge, it shows your name. See first time, second time, third time, and so on. You can see a lot of people. Well, my first time. That's but I myself started to do that like so go over there. You see a lot of rooms. Startups reading your someone the idea mix to random people. Get the feedback and then yeah, that's a really outside I think like you're are you on the selection of the bus? It's like other events that I randomly do some of this the next start. But top one is always the same. Yes. Like 6 years. And then at the same time, also after graduation, I started teaching. This year, I switched to companies, and now I will.
The reason I'm asking is because
My God. Things have changed so quick.
Whatever idea you don't copy which has done the same, has the same purpose. Like they don't have more features. Or like, yeah, like.
Honestly, you know, your time.
We should not. Still give us time for the so how much added? Idea கொடுக்குற audio வச்சுக்கோ.
If you just focus. In a battle with lots of other stuff. Versus if you have this. Something that data science, analysis. You have a much higher chance that it's not the memory. I personally think that. It's very illustrious. Like, if you're a big company, so I love this. I will not. Last thing. 10 years. Recent. There's this. Somebody else, like, well, what the junior can do, AI. Yeah, so you need to do it. And look at the. Everybody is always good. I think if you go to do ML. 2 years ago. Like, I think lots of people. We want someone that understands. Kind of like. You want.
అప్పటికి కరెక్ట్ అది ఫస్ట్
Much better than that. So I think. Focus on what we are.
Both lenses it's on 9 billion. No, just for that.
And that was not for local. Previously, the government was just, oh, we export 100 years now. We need to learn how to cost more clusters because the water is on. Still isn't really, but multi, like mobile bus. We will have it. So we want to get into small as and only rush the search. Teaching with the lab. Labs, but lost some. But you have the other classes. Better for yeah, so but obviously that try to finance and that's something that you know from your Yeah, your partner in so I personally don't know. I don't bias, but Right. But that's been like the revolution that's been sent, which you know, everyone's kind of like we. But I wouldn't recommend you to focus on avoidance strategy because that's something we should really. One thing you can do is that you don't want to bias by certain like as one of these AI tools. But the position. And try to sit the wrong dose with the one you in search. So that I was talking about this problem. Both something like that, so you can. Ask why. 2 days. So the first when I say that, okay, then let's start with the book. Pass that. Now, as we go through semester, somewhere, who was it? You can go.
Since in my team, we do not have anyone with CICD, like hands-on.
It's last week they did say
But like for, I'm talking about from project, like someone, because as we.
So if you learn what was the GitHub action task class, we will talk about the phase of CIC. There's one other lab. We can go over it, but that's technical specific. You have a new code comes in and integrate the testing and then deploy it and where it's the platform.
From the point of view, how would that come into picture? Because so previously, since I've worked as data analyst, I know, like, continuous updating of the data set. But that's kind of like mess when you're.
The where it comes. Pipeline that. You have a pipeline, so the pipeline needs to update.
Yeah.
And that's part of the audio show pipeline. So that means there's a new data comes, you update some code, send that code that says it triggers that, send it to the cloud. So that would be built.
Okay, that's true. So I'm like just like the new data coming in and the whole model is not getting. Yeah.
We haven't talked next class we have here. Is it DVC? That's the data version. We will go on the data version, which connect it to the we will get videos, but if you haven't done sales, redo the labs and put something around again.
So basically, that's where I'm not that confident in the.
So review the lab, watch then schedule time with your teams. You have 60 days, 6 hours that use it every day until you learn the sales. If not, then. If you couldn't find the team member and you are not complete, send your TAs a name, the name of your group and how many you have and which area you're lacking and try to.
So with the project, you posted here, I'm trying to come up with project like the hyperlink, what are the main things? Obviously, it's work with the machine learning. What are the other things? We need to have the continuous, some type of, some field.
So the great thing that you guys.
Are you gonna? Can you post maybe the previous semester projects?
Yeah, I'm gonna show you that. So we have this website for previous semester projects. So this can give you an idea of, I don't know, like what they built. So you have this in scoping, for example, what they scope.
Okay.
This one is maybe not introduction. Let's see. This is what comes out of end-to-end pipeline. So many components. That's why I would say that you cannot do 4 students. You will get confused. It's not other project that you do in the classes. You actually need to build something that from top to bottom can go through and every piece works with the grade. And also don't feel scared by it because you will learn it. You know, it's a talent that it's something that any engineers in any company will finally learn. You just need to connect this together. So as we go through, you build, so go to this, you can find all of this